Hey everyone, this is the intro video for how to create a virtual pet game in Unity. I am Ramon Lopez, aka Ramon Dev, and you can also find me as Natural Power Games, which is my game company. We're going to talk a little bit about what the project is going to be. I'm going to show you the finalized product that we're going to obtain after doing all this project. And of course, I'm going to probably save some spoilers for myself so you guys have some mystery. But let's go over the objective of this project is to create a full-on virtual pet game in Unity. You can see here we have, this is actually randomized background, so I'll show you in a second. If I hit play again, we'll get another different set of clouds, a different set of mountains, and we can also get like nighttime gameplay. Well, you can see that the clouds are moving, which is pretty nice. So we have randomized backgrounds, we have a pet that has animations, and this is only one graphic. All this animation is done by using a tool that Unity provides for free called Animation 2D and 2D-IK. And you can see that this guy moves around, and this guy has several animations that I will not show you now. Nope. You have to go in and find it for yourself. We have bars for the amounts of happiness and stuff. We can set the time that it takes for the hour to pass. So I'm going to just change it here so you guys can see how this values reduce. You can see that they're reducing themselves now. I'm going to make it even shorter. And this gets saved. We can save and leave the game for a few days and come back, and the values will be updated: days, minutes, hours, seconds, whatever years, and the values will be updated properly. And we also have a mini game. I shouldn't show you the mini game actually. I'm going to turn off the background. So I'll just show you the mini game. We have 30 seconds. We have to capture, or rather save, these 3 bunnies, and you can see that I'm moving the pet right here. We have a pause button, and we can jump to catch each one of these guys. I'm a flying pig, so I can definitely do that, and I can just go ahead and catch my friends and fall very slowly because that's the way it is, and then we can just catch the last one. And if we do catch it, and before the time runs out, we get our victory screen, and then we can hit home and we're back to the base screen. So that's basically the game that we're going to be making. I hope you guys are really interested because I'm really excited to make this game happen. So thank you for watching, guys. I'll be back. Not be back, just let's start with this. I'm gonna do my introduction. I'm Ramon Dev. I have been working with this for a long time. I have worked with Robot Sea Monster games. I have worked with many small game companies. I've also worked with fast microservices in Indonesia doing software development. But the thing that I love the most is game development, because game development is a soul thing. It's a heart thing. It's a passion thing. So let's go and burn with our passion and create this virtual pet game in Unity. Thank you for watching. Alright everyone, welcome back to how to create a virtual pet game in Unity. This is session 1.1, which is called installing tools. We're going to be, of course, installing all the tools that we require for our tutorial series. This way we will be all up to speed with what we need, and there will not be any outliers. Of course, we don't want anyone to stay out of the loop with these tools, and we want everyone to be able to follow along these tutorials. So let's check out session 1.1. So session 1.1 is all about installing tools. So I'm going to be installing Unity. For installing Unity, the first thing that you must do is just go to unity3d.com over here, and in here you have many things. You have a lot of options that you can do with Unity, but of course the first thing that we want to do is just get Unity over here. And we don't really deal with Plus or Pro because we're just learning. We're gonna go for Personal. I am using Plus, and you will see the difference in a second. So I'm gonna click on Personal, and you get a free version of Unity that does not include support, training, and services. So since this is a tutorial series, we don't mind too much. We're gonna click on confirmation that we agree with their settings, their terms of service, and we meet their criteria. we cannot make more than 100,000. We have not raised funds in more than 100,000, and we're not currently using Unity Plus Pro. So we're gonna download the Unity Hub here. So you can do two things. You can either download the installer for Windows, or you can download the Unity Hub. In this case, we'll be downloading the Unity Hub. You can see that I've downloaded many times over the few last tutorials just to teach people, total 6 times. So we wait a little bit and then we click on it, and it will be, of course, launching an installation. Then we want to wait a little bit for it to react. And it's not reacting, so I don't know why. Let me check my downloads. I click on it again. There you go. So now we have license agreement, push review, the license stuff. Oh, it was already up. Oops. So I'm gonna agree with this, and I will click install, but I'm not gonna click install because of course I already have it installed. So after that, you just open this new thing that you got. Okay, and now we open the Unity Hub. So to deal with the Unity Hub, what we will do is we can go ahead and check we go to the installs part. So in the installs part, you will see which installations you have. You will see the official releases, and you will see the beta releases. So in the beta, yeah, they even already have 2019.1. So in the official releases, we have the most recent one is 2018.2.15 F1. My current version is 0.14 F1. And about compatibility, about future stuff, about backwards compatibility of this tutorial, we will be able to see that this is going to be compatible for a few years. So basically we can just adjust this and like use this, and in the future, if you're seeing this tutorial like a year from now, they're going to be probably at 2019.1, but it's fine. You can still use the same version and there will not be many changes. Maybe you'll get updated assets and everything will work more smoothly, but you know, it doesn't matter really what you have, what you don't have. It's not like a race. You're fine with using, if you want to do this tutorial with 2018.3, you can still do it, doesn't matter. Okay, let's go to projects, and I'm going to create a new project over here on the top right. You can click on new, and then we have new Unity project, and I'm going to create it, and I'm going to call it virtual pet tutorials. And I'm going to use the 2D template because I'm going to do a 2D basic 2D game. I'm going to choose my location, and we have the version over here, and I'm going to do create project. So I'm going to just wait until Unity does that stuff. While Unity is doing that, just to save a little time, we can go to Visual Studio. We can go here, visualstudio.com, Microsoft.com, and we'll see that we have the Visual Studio website over here. So now we have Visual Studio IDE, Visual Studio Code, and all this stuff that I have no idea what it does. So you can download whichever you need. You can download Visual Studio Code or Visual Studio IDE, but I recommend Visual Studio IDE. I'm going to hit on Community 2017, and they will immediately start downloading. There's not much more to do, and you can see that Unity is just working on their stuff. And yeah, you can see that I have a Ganondorf as my background on the screen because Ganondorf is awesome. So I'm going to click on VS Community. I'm going to run this installer. You will see that it will just install. It actually installs an installer. So now while it's installing the installer, after this we'll get this new screen. So this new screen that we'll get, I hope Unity doesn't interrupt my explanation. Okay, it's fine still. This installer that we're going to be getting is going to have a screen that this is not the one that you will immediately see, since I already have Visual Studio installed. This is not the screen that you will see immediately necessarily. You can see on this side that I can go and hit modify, and when I hit modify, I will actually see the installation window that you will get. So now we get this beautiful stuff, and the stuff that you need. You may be tempted to come here and do mobile game development with Unity, but don't do that. What we want to do is .NET desktop development, and then we'll go to individual components. And in individual components, we'll go down to games and graphics, which is over here, and you can choose to install Visual Studio Tools for Unity. That's the only thing that I would recommend that you get. When you get that, you will be ready to work with Unity in Visual Studio. So you just get that and .NET Desktop Development, and that's it. That's basically what you need to do. Then you click on, it's gonna not say update, of course, it's gonna say install on the bottom right over here. I'm gonna show you in a second, it's over here. You click on install here, and that is all that you need to click for your Visual Studio to work with your Unity installation. So after that, Unity is already loaded, and we can see I have my black background. This is my dark Unity version. You get this when you have Plus or Pro. So if you like it, or you want to help the Unity people, which don't really need much help, we need more help than them. But yeah, the next thing that I will do is I will install the other tools. So I'm gonna go to Window, Package Manager. This is like on the window menu, and we can see that we already have some stuff installed. We have Ads, Analytics, In-App Purchasing, TextMesh Pro. We will probably not use this, but you will see. We go to the All tab over here, and we have 2D animation. We will install 2D animation and 2D IK. So I'm gonna go click on 2D animation, click install, and it's gonna be installing the free package that is gonna help us animate our character, our virtual pet in the future. Of course, we have to be ready for anything that we may need in Unity, because you have to be planned. You can never really try to work without a plan, and my plan is to have this 2 assets that will probably should really help me set up my animations. I'm gonna have one full tutorial teaching how to do this. So we have 2D animation. Now I'm gonna install 2D IK. We'll wait a little bit. Okay, this package is a little bit smaller, so it shouldn't take that long. There you go. So now we have 2D animation and 2D IK. So the next thing that I want to do is I'm gonna change some scene settings. So you can see here that we have a 2D scene, we have our sample scene, our main camera. I'm gonna change the name of sample scene to be main, because I don't like the name sample scene, to be honest. And I'm gonna create a few folders. Don't forget that you always want your project to be really well accommodated. You want something that you can work with and not get lost in every single time you open it. So I'm gonna create a folder called scripts, and I'm gonna create another folder, and this folder is gonna be called the resources. You are supposed to put in anything you may want to call from any script. So I'm gonna create one called art. I'm gonna create one called audio. I'm gonna create another folder called animations. And finally, I'm gonna create a folder called, whoops, I don't know what I did. I'm gonna create a new folder called prefabs. All right, so now we have these folders. I will go ahead and in the scripts folder, I also need some further organization. So I'm gonna create a folder called abstracts. I'm going to create a folder called abstracts, the controllers, and I need managers. And in controllers, I will create one more. I'm gonna call it UI, because I want some UI controllers, of course. So that is a basic setup for any Unity project that you may have. You will want to set it up this way. You just want a folder structure that lets you work with this stuff and not get lost. The other thing that we will need is we need some assets, some graphic for our pet. That's for sure what we need, and we also need some small UI assets. So I'm gonna go to the asset store to get those right now. That way we get them off of our backs. Also, I actually have some saved, so I'm gonna go to all assets. Oh, no, rather, I'm gonna go to my profile over here, and then click on public profile. Maybe no, that's not it. Impressive new assets, shop on old store. Maybe that's what I need to. Oh, okay. So here in the favorites or my assets, I'm going to show you my assets. I have a few great assets, but I don't want to use any paid assets, so I'm going to use free assets, of course. I'm going to use Simple UI by Unruly Games. This will help us with, it has so much UI, so many UI graphics that you cannot go wrong with this one. It's also free. So I'm going to click on import. It's going to be decompressing the package. Unity is going to be calculating all their stuff, and I'm going to eliminate the samples because I don't need them. I'm going to click on import now. It's going to be importing all the package items. Of course, it has to do their calculations correctly. We wait a little bit while that's working, and after that's done, okay, it's still calculating stuff. So that's the first thing. We need UI stuff. The next thing is I want some sort of virtual pet. Of course, I want some sort of animal, some sort of creature, some sort of anything that we can work with. Let me check. You can go to Simple UI. Actually, I want to move the Simple UI to art, the art folder. So I'm just gonna click on it over here and drag it to my art folder over here on the bottom left, and it's gonna just be moving all those files onto the art folder. And we have over here, we can check the resource icons. We have some resources. We have some simple vector icons, which are great for using on our game or any game that you may want to do. They're free. Just remember, Unruly Games, and they also have other types of assets. They have all these PSD logo templates, and this is like just this but spread into two basically. Okay, so now I'm gonna check a pet. I'm gonna check a pet, and of course I'm going to be changing the price to be free and see if we get something cool here. We have some faces, which is not bad. We have evil fire demon, which is not good. And what else do we want? Tomb witch, tomb demon. They're just meshes, so maybe we can find something better. I think the face is not bad. First person lover. Okay, so I'm just gonna go ahead and click on this pack pets, match 3 pets. Okay, so this is basically a match 3 game package, and we'll see here pack AI PSD PNG bear, black bear. We'll see the picture over here, which is fine. We can get one of these to work. Yeah, this is fine. We can definitely get one of those to work. So I'm gonna go download this match 3 pets sprite mega pack. We will use one of these as our virtual pet, and we'll be animating it very simply so that we can get some emotion out of that asset, out of that picture, out of that pet. Alright, so after this is downloaded, we're just gonna be importing it into our, of course, our art folder. And I'm not decided yet on which one we're gonna use, but we will definitely use one of these. So pets packs it's good that you check the version number. So it's a supported unit versions 5.0.1, but since we don't have, they probably don't have any scripts, we don't really care. We can just set this up the correct way. So Unity, I'm gonna hit import so that Unity decompresses and thinks about it. And we have auto run, canvas, more game, editor sample. I don't want any of that. I don't want any of these editor things. In your editor pop-up, I want to pop up on my editor. I don't know what that is. I only want the pack itself. And out of the pack, I don't want the AI, and I don't want the PSD, and the screen. Okay, I'll get it. I don't want the AI again. I'm gonna hit import now so that it imports the package with the very small amount of pets that I chose. Again, remember that anytime that you need anything, you can just go to the asset store, especially for graphics or simple prototype graphics. You can just go to the asset store and do that. So pets pack, we have the pack, we have the PNGs, cat. You have several types of cat, which is great. And okay, the next thing that I will do is, I think that's it, right? Yeah, we do have all the tools that we need. We have Visual Studio, we have Unity, and we have some assets and some small setup. And we also got animation 2D and animation or rather 2D IK, which is going to help us create some basic animations for our pet. And that is basically it for this tutorial. I appreciate that you guys watched. We're gonna come back in a second to do session 1.2, which is checking a virtual pet examples. Is gonna be another theoretical session, which was just gonna be me explaining what a virtual pet is, how do we make it fun, why we're doing a virtual pet tutorial series. So thank you for watching, guys. I'll be right back. Alright everyone, welcome back to how to create a virtual pet game in Unity. This is session 1.2, which is called checking virtual pet examples. So the first thing that comes to mind whenever you're talking about a virtual pet is the classic virtual pets, which are the Tamagotchi. So the Tamagotchi were a big phenomenon back in the day, but Tamagotchi was one of the first handheld devices, one of the first portable gaming experiences that people got. It was aimed to children at the start, but then the creators realized that they had a big thing in their hands when, of course, it started selling a lot in Japan. And when they brought it to overseas, to America, to the Americas, basically, they adjusted the model and they created several types. They stopped making them only pink, they made it red and also blue and other colors, so that it would be more appealing to young boys. And also many adults, especially in the well, not necessarily adults, but let's say also teenagers, they started playing with Tamagotchi. And so what was the drive to play Tamagotchi? So the drive to play with virtual pets is always that you have something that you can take care of, and it only needs just a little bit of care every certain amount of time. And it was also one of the first experimentations with connection. As you can see, Tamagotchi connection, you could interact with other pets. You can go to their house and play with them, basically. Other types of pets like the Digimon virtual pet, it lets you fight with other pets. And the whole point of a virtual pet is that it has a few UI objects that allow you to interact with it, not completely directly. So this is the base old Tamagotchi. So it's one of the most famous types of virtual pets. Also, the virtual pets can evolve, virtual pets can level up, they age and they die. There's no way to avoid that they die. Before, people would be talking about the fact that maybe they could not die and stuff, but yeah, they always die. So let's talk about other types of games, other Tamagotchi examples. So we have this guy. This guy is a shark type of Tamagotchi. As you can see, they added many things. We have games, care, inventory, shop, outdoor, and we have all the levels. In this one, you cannot see the levels. You can only try to feed the pet, and if it gets fed too much, then the pet will be too fat. If it doesn't get fed enough, it gets skinny. If it maybe it will get sick if you don't feed it well, if you feed it too much. There's a lot of variables in the way that this Tamagotchi stuff works. And so what people have been doing is just changing the virtual pet to be more fit to the mobile space. So how do you make it more fit to the mobile space? So the first thing that you do is you add energy. You have mini games. You also have games in this one. You have mini games, and the thing with the mini games is you get double reward. You get the satisfaction that the pet is playing a game, and you also get the satisfaction that you are having fun with your pet. So in the mobile space, we have this little energy thing that most of the mobile game space uses. Sorry about that. And we can definitely see how it can be implemented, not to say applied, to any game, so that you play a couple games and the virtual pet gets tired, you send it to sleep, and you have to stop playing the game, basically. We also have this other game called Meep, and Meep is much more closer to what the old Tamagotchis look like. It's just a blob. And you have games, you have food, you have light for it to go sleep. And one of the most famous Tamagotchis, there's two of them that are very, very famous actually, which are my Talking Tom, which is this guy. He's a Tamagotchi that you can talk to and he will respond to you with exactly what you said. And we also have Nintendogs, which I don't really have a screenshot for, but we do have it. Like you can use, you can play with your Nintendog, Nintendo cats. They made a lot of different Nintendo stuff. And we also have one of the most famous actually, other than Talking Tom and all his family. We have Poe. So Poe is a virtual pet that looks like basically a potato. I think he's like supposed to be like an alien. And Poe is starts off as this little weird blob, and he goes evolving. You can personalize him. You can add clothing, and that's another part of what makes this. What they changed to go from this to the mobile space. They also added a lot of collectibles. You can collect clothes for the pet. You can collect different types of items for the pet and make it, you know, a little more unique, a little reflect your mood. There's many advantages on this collection stuff, as you can see here. I'm just gonna show you. So Poe can become some sort of Boy Scout, can become an entrepreneur, a girl, or a bee even, so like animals and stuff. And some people have actually made other interpretations, but I think this is not real. I haven't played real Poe enough to get this, but yeah, Adventure Poe. So you definitely can get a lot in this mobile space with a virtual pet. And there's another one, and yet another one. As you can see, the space, the market is there for these virtual pets. And let me show you this mini game that they made. Is basically Mario. So you just move from left to right, and you can stomp on things. And you can see that this is just a Poe mini game, which you can use to that's called Virtual Pet Run. And what they do with this mini games is just adapt famous gameplay mechanics like Mario, or Doodle Jump, like going up or going down, or grabbing coins, or infinite runners, or all these types of gameplay mechanics that you know that are there, that exist in the world of our already created games, but they are not innovating. So just creating this mechanics and adding it to this game. I'm going to show you a screenshot over here that has a bunch of mini games. So this one is an infinite runner. This one is also an infinite runner. This is one of those Candy Crush clones, and this one is just a Doodle Jump clone, basically. So, and also you can also add all of these options in the. You can see that you can go to the shop, buy food, achievements, all these little things that make a mobile game more attractive for children, for anyone. For example, my mom loves her Poe. The clothing is what she likes the most. So you can see that it's attractive to people to be able to set up their Poe. If you have like team clothes, for example, like country team clothes, you can just add these clothes to your Poe and make your Poe into. For example, if you like the Spain team for soccer, then you can just dress up your Poe as the Spain team for soccer. And just take a screenshot, share it on Twitter, and then that conversely will get more downloads to the game. And that's the whole point. You're trying to find a way to get an active community of people who are playing your your virtual pet. So stepping back a little bit, let's talk about, I'm going to do a small recap here about what I talked about so I can finish the video. So basically, we have several elements in a virtual pet. What we have is, this is mobile space, so this doesn't really count. But here we have something better. We have food, health, I guess this is health. This is mood, I guess, and that's energy. So we have 4 types of needs in our virtual pet, and we have several icons. We have UI showing us what to do. We have simple UI showing us like the fridge, shop. If we were to create different screens like this, we will definitely have to create this sort of thing. But going more simple, which is of course going to the basics, which is what you need to do to learn how to make a certain type of game, we have small icons, and each icon does one thing, and that's it. Like the icon will allow you to interact with the pet in one way, satisfy one of the pet's needs. So if the pet's hungry, you can satisfy the hunger. If the pet is sick, you can heal it. If the pet is dirty, you can clean it, if that's included in the game. I mean, I don't know if that's included in every single virtual pet. I don't think so. And if you want to play in the latest ones, if you want to play a mini game, you can just click on the mini game UI button and you will go ahead and play as long as the pet has energy. And if it doesn't, you have to let it rest for a while, which is one of those mobile game practices that I guess we all love, right? So yeah, mobile games with their energy mechanic, it's like permanent for mobile games, but we are not really making a virtual pet mobile game. We're making a virtual pet game. So I'm just giving you a little suggestion, a couple suggestions if you want to jump into the mobile game industry with this game, which is totally possible. So yeah, thank you for watching, guys. That is examples and explanations of what is a virtual pet game. Now we're going to go ahead into session 1.3, which is scoping a project. We're going to be talking about a little about what's going to happen in this project, what I might add, what I might remove from the project, depending on how it all moves forward. So I will be right back. Alright everyone, welcome back to how to create a virtual pet game in Unity. This is session 1.3, which is called scoping our project. So what is going to be the scope of the project that we're going to be creating in this tutorial series? So basically, this tutorial series is made up of a few parts. I divided it into a few parts to control what's going to be done, to change the next part depending on how the previous part went. I have my good expectations. Of course, I have coded a virtual pet before, and I went real far with it. And so we're going to be coding a prototype version of that virtual pet. So what is the extent of what we're going to be doing? Are we going to be creating a ton of mini games? Are we going to be creating a lot of sounds, a lot of animations? Well, no. My idea here is to teach you to control. What's up with this? I want it to be smaller. I want to delete this. There you go. So I want to teach you how to make a Tamagotchi wrapper, basically. So what's a Tamagotchi wrapper? What we want is to have a Tamagotchi that can do what a Tamagotchi does and that you can add to it. So I'm going to leave open the door for your creativity. Basically, that's what I try to do on all my tutorials, but apply to this one. I'm going to open the door for your creativity so that you can go ahead and modify and apply and invent into or onto on top of what we're going to be making in this tutorial series. For example, we have in this flow we have fridge, shop, orange, blah 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 blah. So I'm not going to implement a bunch of types of food, but I'm going to implement the feeding mechanic, and then you can add the food. I'm going to talk about how to add it, how will you create a UI menu to select the food if that's what you want. That is a good idea actually, but it doesn't reach, our scope doesn't reach that far. We don't want that. We don't need to have oranges. What we do need to have is the pet needing to be fed, and of course we also want the pet to be able to eat. We want the pet to be able to get sick randomly. I don't know how I'm gonna I'm not sure if I'm gonna implement that one, but we want the energy to go down, the food need, like the hunger meter to be depleting. But I'm gonna probably do this, and this, because this one is very subjective. It's a very rule heavy thing that you may want to detect. But yeah, we don't. For example, we're not gonna do coins. We're not gonna do a camera. Why would we do a camera? But we will do other stuff. We will do some animations. Well, you can read the course, we can check out the curriculum that I already wrote, and you probably watched the intro video, which will of course give you more information. But at this point, what I'm thinking is, if I don't have enough time, I will not, of course, fix all the bugs. I would fix the more important stuff if there are bugs. I don't think there will be, but if there are, I will only fix the more important stuff. Because session 2.3, for example, is called time passing and fixes. So the time passing depends on saving. We're gonna be saving a file with JSON, and then we're gonna be loading that file whenever the game restarts, so that we can have a time passing effect. Also, we have the UI, we have the mini game, the easy mini game to create that we're gonna be coding in session 4. And then if we actually have more time, what I will do is I'm gonna add some sound to the animations. I'm gonna add some more interactions, and I do hope that after session 4.3, I can do a session 4.4, which would be something like fixes or polish, and we can add we can do a polish round with sounds and all other stuff, coding improvements basically. So yeah, that is the scope of the project. It's gonna be a project where we're gonna do a prototype type of feature, and after the prototype type of feature, we are going to finalize this with a simple basic mini game. It's probably just gonna be like catch something falling from the sky, and if you catch the wrong thing, you die, or something like that. It has to be very, very, very simple. Alright, so that's it. That's basically it for the scope of the project. If you guys have any questions, if you guys want to suggest anything, just send me a message on the website or email me or something like that, and I will definitely help you with anything you may need. And I'll be right back with session 2 intro, which is virtual pet based setup. Thank you for watching. Alright everyone, welcome back to how to create a virtual pet game in Unity. This is session 2 intro. So session 2 is going to be an interesting one. I'm going to go back to Unity here real quick. So in session 2, we're going to be creating the pet controller and the animation. So of course the base pet controller that we're going to be creating is going to be something real simple. I'm going to just be allowing other scripts to access the pet controller and ask it basically to generate the animation. So the first thing that we'll do is going to be creating the animations, then going to be creating the script, or vice versa. It doesn't matter too much the order, and that should take us a little bit, but it's going to be well worth it to have the animations. I'm going to show you how to use the tool called 2D animation, 2DIK. If you have seen my previous project called how to integrate amazing Unity plugins to your game, then you probably already know, but it's good that we all get up to speed with this amazing plugin that Unity lets us use for free in any game that we want. And after that, after setting up the pet controller and the animations, we're gonna be in session 2.2, we're gonna be generating the needs and the satisfaction of those needs. So what does that mean? That means that our needs, which is basically let's call them hunger, happiness, and energy, are going to be depleting over time. So we're going to be getting more needy basically. So we have a hunger bar from 0 to 100, and if it reaches 0, then we are really, really hungry, and if it reaches 100, then we're not hungry, which is, it may sound a little weird, but it will work, trust me. And then we will satisfy those needs by having functions, which is not going to have UI yet. I'm not sure. I don't think we will have UI yet for it, but we're gonna be creating functions to feed the pet, and that's basically session 2.2. It's gonna be about needs, about the satisfaction of needs, maybe about whether the need satisfaction or having extreme needs will do something to the pet animation wise. We're gonna be maybe creating animations for each need. So if it's too hungry, if it's like maybe from 25 to 0, which is very, very hungry, the pet will be doing some sort of face, some sort of expression. Maybe the game will do something about it, some sound, not yet sound, but maybe that's an option. And then we also have the satisfaction of that need. So if the pet gets fed, what happens? We will have a function. It's gonna be called feeding. So we need to communicate that to the pet. So you are being fed right now, play an animation of happiness or something. What if the pet gets played with? Maybe it will get happy. So that's session 2.2. Then session 2.3 is a little more technical because it's about time passing. I have made a virtual pet before, so I will show you how to make the calculation to know when a save was applied. So we're gonna be saving the last time that the pet was fed, and what was the resulting hunger after that feeding. So if the player saves the game, every time the player saves the game, not maybe every time the player feeds the pet, I'm not even sure yet, but every time this is changed, then we're gonna be saving, and then when we reload the game, the pet will know what was the last time that they were fed and when how it's gonna be working. So that's gonna be a little technical because we have to save in JSON. We have to create the pet controller. We're gonna save a pet. That's gonna be an abstract. I might just create the abstract folder. I think I actually created the abstracts folder. Yeah. So the pet is gonna be an abstract. It's gonna be saved into JSON. Then we're gonna load from JSON so that we can know our data for the pet. So section 2.3 is about time passing and fixes, which is more about saving, loading, and calculating stuff. And we're gonna be googling stuff. We're gonna be learning about all these calculations. We're gonna be learning about how to properly save data in JSON format for this type of situation. So it's gonna be a really exciting couple of tutorials. This is gonna be the very, very groundwork. The more important part of your virtual pet is gonna be creating in this next about 2.5 to 3 hours that we're gonna be doing session 2.1, 2.3. I mean 2.1, 2, and 3. So let's hit it on, and I hope you guys are ready for this action. So thank you for watching. Alright everyone, welcome back to how to create a virtual pet game in Unity. This is session 2.1, which is called pet controller and animations. So we're going to be creating a very basic pet controller and some animations, of course, for that pet controller. So the first thing that we must do is we must choose one of these pets, and I'm gonna randomize it, and I'm gonna choose the pig. So the pig looks real nice. I'm gonna get this pink pig in our screen here, and that is going to be our virtual pet. You can see that this guy is looking pretty nice, pretty crisp in our screens, and which is awesome. And I'm going to be, what is gonna be happening here is I'm going to be editing its sprite to work with that amazing asset that Unity added, which is called animation 2D and animation IK. So the first thing that you do to do that is you click on the sprite here. You can see that it's already imported as sprite to the UI. This is all fine because we don't need much precision or anything of that sort. Actually, maybe we don't want to filter it, and it's still gonna work exactly the same, but we're gonna be adding or changing is going to be going to the sprite editor over here, and you can see that the sprite is very cleanly cut, so it doesn't have much white space, doesn't have much transparent space, and of course we cannot really make too much out of the sprite, or can we? I think we can. So I'm gonna go ahead and click on, we have all these two new options because of the animation 2D asset. We have bone editor, and we have skin weights and geometry editor. So the first thing that I'm going to do is I'm going to go to my bone editor. So what is the bone editor? The bone editor allows you to, as the name says, add some bones to your structure. So I'm going to click on this tool on the bottom right, and this tool, what it says is, what it does is whenever I click, it will add a bone. I can just click once, I'm not dragging, I just clicked, and I can select the way this bone will work, and I can actually delete that bone. And you will ask yourself, well, Ramon, what are you going to do? You only have like one thing in your whole, you have like the 2 years, and what are you going to do? So basically I'm going to be creating bones for each one of these small structures, and I'm going to connect those bones. So I'm going to have, we have the ear, and the ear actually divides in this like this, and that is our ear. We have 2 bones in the ear, 1 and 2, and I'm going to be doing exactly the same for the other ear. So I'm going to click on this, and you can see that it tried to connect them, but I don't want to connect them, so I'm gonna check out the there's a disconnected bone thing here. So well, that's fine, I guess. This is fine. So they're connected, but they are afar, so we click like this. Now I click on this bone, and I click on this, the bone tool again, and we can create a second nice horizontal bone for our ear, and that is the base head bone structure, well, the top of the head bone structure. As you can see, I also want something else. So I also want, you see that they don't really let me like separate these bones. So I'm gonna be creating a bone. Actually, I need a bone like in the middle here. But why do I need a bone in the middle there? So that this bone in the middle is like the governor of everything. So maybe I can actually just create a bone over here. What is, I wish, the only thing that I complain about with these bones is, this bones thing, is that it doesn't really have, the ability to, well, you can see that I can just do that, but it doesn't have the ability to create a separated bone. So I don't know how to separate bones or anything here. I don't know what that is. I don't know what this is. I created like a secondary bone here, which is pretty strange. I'm gonna delete this bone, and I will just change the structure just a little bit. So this bone is gonna go over here, and I'm gonna click this so that I can create, whoops, this bone over here, and this guy is our, like, the middle ground governor of everything. Now I can click on this, and I can click on the disconnected bone tool, and I can go ahead all the way down here, and I can create a couple more bones with this. So the first pair of bones that I'm going to be creating is actually the eyebrow bones. So I'm gonna go ahead and click on this. We have the left eyebrow. I'm gonna go here and click on this, and I'm gonna create the right eyebrow. And then I'm gonna go down, and I'm gonna be creating all the bones, the bone for the nose and the mouth, basically. So I'm gonna have my mouth bone over here. It's gonna be, let's say, like this. I'm gonna move it here. This works fine. And I'm gonna move this so that I can see that it works the way I want it. So now we have a basic bone structure. Our little pet, which is only a face, already has, bone structure. So with this bone structure, I go ahead and I'm gonna apply that. I'm gonna make this a little large. I don't know why it went all the way over there, but I can just adjust this again to be the way that it should be. I don't know where that bone went. There we go. No. It's like stuck there. I don't know why. So this guy should be down here, and this other guy should be over here at the eyebrow level. So I'm gonna be, sometimes the tool has some settings, some failing settings. I don't know what this is. And so, oh, this is actually a bone here. So that's probably why. When I hit apply, you can see that it now works correctly. So I'm gonna go back to the skin weights in geometry editor. So we're gonna be generating the shape. I'm gonna generate this. You see that the shape is all wrong. But first, I'm just gonna go to weights, and you will see that it's all black. So why is it all black? Well, it's all black because it wasn't generated. So I just hit auto, and now I hit apply, and it's all well generated and stuff. So we can see the bones, and I want to deactivate the graphic overlay. Maybe there you go. So we can see that if I do that, the ear will move, and if I do this, oh no, that's not the way it should be. It's not well connected basically. So save maybe. So it seems like there's two graphics, one on top of the other. That's weird. So yeah, this is not correctly set. This is not, the bones don't seem to be connected. Also, like the shapes don't seem to be working right. So I'm gonna create edge here. I'm gonna be setting the graphic a little better. I'm gonna check the bones actually. I'm gonna go to my bone editor. I'm gonna apply this, and I should have like a middle bone that renders everything else, like the sides, everyone else's thing. It should be this one. So this guy should be like the governor of all other bones, and these guys are just temporary bones, like minor bones basically. I don't know why it's like that. Okay, we move all the bones. Oh, okay, so this bone is not really connected to this guy. So that's better. We are just dragging and moving the bones the way they should have worked from the start, so that we can get a good bone structure here. I'm gonna apply this now. Let's see how that works. Let's go to the skins and waiter. Always this generate. I'm gonna outline detail. Okay, that looks better. That's way better. And now I'm gonna do generate for the other stuff, the weights. See that it's more local. Oh, this is a problem. This guy really does have a problem. So I'm gonna do that. Why are you moving everything? Why is it moving everything? I'm gonna click on this bone. Oh, whoa. That's why. Okay, so what's going on here is the first bone that I created. I'm gonna make this large again. So the first bone that I created is the root bone, which it should not be, because this should be the root bone. So I'm gonna delete this bone, and you can see that everything got deleted. Well, I'm not gonna delete it. I'm just gonna move it so that it sits here. Well, I'm gonna just have to delete everything. No. Okay, so I'm gonna create the roots again over here, but the root's gonna be the right bone, which is this. The neck bone is the root, and from this we do this, and this is our eyebrow, and this is the other eyebrow, and this is the mouth, and this is the right ear, and this is the left ear. And we can extend this bone by clicking this, doing that, and then we click on this and we extend this bone doing this. I'm gonna apply that, and then we go to generate the weights, and now it should actually, yep, it will behave correctly. So if it's like this guy's talking and stuff, pretty nice. We have our bone structure real well set, and this is actually the root, so we can move the bones, like all the structure with this one if we need to like do some happy dancing or something. You can see that this works just fine. We could also change the way that the bones work if we needed to, but we don't. I think this is working just fine the way that we have it at the moment. So I'm going to be applying those changes. We have our little peg working the way that we intend to, and now the other thing that we have to do, which is it's the IK, but the IK works a little differently. I'm gonna drag this guy onto my scene, and you see that it actually, oops, what happened here? Cannot parent the bone to itself. Whoops. Can I add the sprite? skin, is that it? Root bone, no. Edit, remove. Sprite editor, bone editor, we have the bone structure, but I cannot see the bones. Why can't I see the bones? So whenever you have this sort of doubt, you can go to the package manager, 2D animation, and we can check the readme. I'm gonna check the, well, it doesn't say much, but I will be adding bone. I don't understand animation 2D. TMP sprite animator. What's that? No. So we should have some sort of way to play with the bones. Let me check the animation. I'm gonna create an animation here. Go to resources, animations. I'm gonna create an idle stopped animation for a pig, and yeah, we cannot play with these bones for some reason. So I'm gonna go to my project assets. So basically, when you are a little stuck with this, you can go to the package manager, you can check animation, you can view documentation, and that will bring you to the website that has the workflow. Oh yeah, you have to add the sprite skin component. So it will show you the workflow. I'm gonna go to add components, skin, I'm gonna add sprite skin, create bones, and we have our bone structure. So remember, this is our creature controller. So we have few things. Well, this is deformation, so it should be fine. I'm gonna go to my project scripts, and we will have we're gonna have a governing, basically a governing object, which is gonna be our pet object, and we're gonna assign the pink pig to our pet object, and our pet object is gonna sit at 0, 0, 0, and the pig also has to sit at 0, 0, 0, so they're very coordinated. And here in pet, I will go into my controllers, and I'm gonna create a C# script called pet controller, which is of course what we came here for. And with this pet controller, we will be adding some small stuff to the pet controller. What do we need from the pet controller? The first thing that we need is a reference to the animator in our children object. So we can do it two ways, and I will do it both ways just to show you. The first way is doing a public animator. I'm gonna call it pet animator, and I'm gonna delete all this stuff. So the first thing that we can do, the first way that we can do this is by doing this pet animator equals get component in children animator, and that way we're sure that we're gonna get the animator from one of our children. But that can be dangerous. Why can that be dangerous? Why is that a dangerous thing? Well, you never know if it actually is there. So I'm not gonna not gonna run any risks, because it's a prototype level project, and I want it to be real simple, real straightforward. So we now have an animator here, and we know that our animator is in this object, so I'm just gonna drag it and drop it over here, and we have our reference to our animator. The next thing that we need to do is go to resources prefabs and add the prefab over here, so that we have a saved version of our little piggy. So what do we need to do in this beautiful controller? Well, the first thing that we need to do is we need to set some, let's call this, we need to set some animations, some communication ways for other scripts to tell our pet, hey, do this, hey, do that. Well, actually, I'm thinking about the consequences of doing this. So what happens when you want to animate an object and you want it to be interacting with the script? Well, I'm gonna click on pink pig, and you just add a event here, and you can use any functions that you have you have communication with on the same object as this guy. So since I actually don't really need any real functions yet, I'm just gonna show you that this function will not show up. So I'm gonna call it public void switch to happy, or rather happy, or display happiness, display, or yeah, happy is fine. Happy, and just gonna be a public void, and it's not gonna return anything. It's not gonna do much. So I'm gonna click on this guy, on this event, and you will see that I will not see the happy function here. I don't get the happy function. So since I don't get the happy function, I can't use it directly from the animator, which is not a bad thing. We will not just not do it. So whenever I want to show happiness, I will do pet animator that set trigger happy, and then I will do that for each of the emotions that I want. So I'm gonna do a couple voids, and they're gonna be, of course, different stuff. It's gonna be hungry, sad, tired. So I'm gonna have I also should do public void eating or eat. So I'm gonna add one of each. So hungry, sad, tired, and I'm gonna copy this and I'm gonna be doing eat. So what is a trigger in an animator? A trigger in an animator is a parameter that you set previously so that you can call an animation like this from any script. This is a very simple animation tool that some people don't like to use, but it's useful for like some stuff. For this, it's fine. There's one other thing that I should do, but I'll do it in a second. Okay, so we have idle stopped. I'm gonna create a list of these triggers. So I'm gonna happy, and then I'm gonna create a new one that's gonna be called sad. I'm gonna create one more that's gonna be called eat, and finally I will create the one called tired. So you will see here that we have happy, hungry. Oh, I forgot hungry, so I'm gonna add trigger hungry. And of course we'll need animations for each of those states. So I'm gonna go to animation. Idle stopped is not gonna be just things sitting there. Oh, I forgot about one thing. I need to create the IK targets. So the IK targets have to be the child of this guy, and I'm gonna go ahead and create a 2D object, or rather component. I don't remember where it is. Game object, effect, euphoria, tile map, hexagonal, no, effect, light, UI. Okay, so I can just do empty, I guess. I'm gonna do an empty game object, gonna call it IK. And this IK target is gonna have all the IK targets. So basically, I'm gonna have 1, 2, 3, 4, 5 IK targets. So I'm gonna create an empty game object. It's gonna be left ear IK, and I'm gonna just test that the animation is saved. Yeah, it's saved. I was just checking that the animation gets saved with children, grandchildren, but it is saved. So I'm gonna show you what an IK target is in a second. So do we need an IK manager for sure? Okay, let me just create. This would be the IK manager 2D, IK solvers. So I'm gonna add a limb. We got a new limb solver over here, and this guy is gonna be my left ear IK. And of course it says target and effector. So what's my target for my left ear? My left ear's bone, which is 14, I guess 15. So this guy here, effector, I actually don't know what that is. So I'm gonna create the effector. Okay, so the effector is like the actual thing here. Okay, left ear IK, and we have our guy. I actually think that the right bone is the bottom bone. Yeah, that's what I thought. Look at this not behaving right. That's so beautiful, right? Restore default pose, and we have our IK target. I'm gonna move it all the way over here. Oh, so you can see the guys like over here. The IK target is, this is the real thing. So I'm gonna place it over here. I'm gonna say restore default pose, and we have our IK target. The effectors over here. And so what we do is we move the effector the way that we want to move the object for the animation. Instead of moving the bone, we move the effector. Also, I don't think we actually need an effector. It looks so good with the effector though. It's moving too much of the bone, in my opinion. So constraint rotation. Maybe I should delete this guy and see how it works. Restore pose. Oh, it doesn't do anything. Do have to create an effector for sure. Restore default pose, and we move the effector as we need to move the thing. Okay, so good. We have our first IK target, so I'm gonna continue to create more IK targets. I'm gonna create another limb effector, another limb resolver. It's gonna be my right ear IK. My right ear IK is, oh, maybe, wait, I'm just gonna check that this guy could work better with the 15 bone instead of that one. Move the effector, oops. It doesn't work, it has to be this one. Okay, so 17 is correct. Now this one will be right ear, so it's gonna be 16. I'm gonna create an effector, restore default pose as always. It is not restoring the pose, I don't know why. So it doesn't want to restore the default pose for some reason. So I'm gonna be moving my IK target like that. So it seems to think, there you go. It seems to think default pose is that really weird pose. So I'm just gonna show it that it's not. This is the right position. I'm gonna add the correct bone here. I'm gonna create an effector. That's insanely weird that it thinks that is the correct pose. It's very wrong. Look, it's rotating. So yeah, it has this weird little things, I guess. So I'm just gonna set this to 0 again. See how we did with this? So maybe I created with, I'm gonna try this, create a effector. Doesn't do anything. It really doesn't do anything. So I will do it again with 16 bone, and again it does this really weird thing. Really strange when you think about it. Maybe I have to flip the animation. The next IK. I'm actually not gonna do any more IKs because I have these bones that, oh, whoa. I have these bones over here that already work by themselves and they're not limbs. We don't need IK resolvers, we can just move them as we wish to move them. And if we want to move the whole body, we just click on this. And if we want to move the position, we just move this guy. Okay, so what happens when my pet is stopped? When my pet is stopped, I'm gonna change this to have 12 samples. But that means there's 12 frames on the animation. I'll probably not use the 12 frames. So when this guy is idle, he will like do this breathing sort of animation. I really don't want you to do that. Thank you. So in frame 3, what's this instance of an object? Animation, blah, blah, blah. I don't care. So we will be correcting this. We will be adding a little idle animation. So whenever this guy's idle, we're gonna change. Okay, so I'm gonna delete that thing, restore default pose, and at the start, this is the pose that we want. Then when we are idle, we want the bones to do stuff. We want to record bone change. So I'm gonna go to my effector, and I want it to be like breathing. So I'm gonna move this in, and I'm gonna move this in. I don't want you to move. There you go, that's better. And I want the mouth to move a little bit, just a little. And then in frame 6, I wanted to restore this same position. So the first position has to be restored by frame 6. He looks a little constipated, but he's fine. So there we go. So we have a little breathing animation. So when I click play, you will see that he's some sort of breathing. He is doing it really fast, so I will change this to actually be every second. So the full animation is going to be played every whole second, so that he doesn't look, you can see that he looks way better. So that's a very simple idle stopped animation. And now I'm going to create a new clip. I'm going to go to my resources, animations, and I'm going to create a happy animation. And to show happiness, I will change, of course, the ears. I'm going to go to, this is going to be a fast animation. It's going to go to 6 frames, which is half a second. Click on this, and I'm going to go to my left ear effector, and this guy is going to go up, like this. Then this guy is going to go like, whoops, not that, like this, so that it's like opening. I'm happy, I'm like wide, and my mouth is wide open, my eyebrows are happy, and my mouth looks really weird. Okay, so that's better. And now we go back to the base pose by 1 second, which is this, and we will see when we hit play that he's like celebrating, looks quite happy, right? Right, it doesn't look demonic at all. Okay, so next thing that we need to do is a sad animation. And sad animation is going to be some sort of like happy animation in reverse. So I'm going to go click on my left ear effector, we click on record, and we want it to be like, whoa, like real sad, like real sad. So this guy is at this position. I'm going to copy this component, and I'm going to paste it on the right effector, like this, paste component values. And he's gonna go all the way wild, so never mind. I thought that would work. So okay, tiny guy, he's very sad. I'm gonna click on this bone and make him like tiny. Whenever you're sad, you compress yourself into a little ball, you curl yourself in. So then we copy the state, the initial state, and we paste it here, and this is our sad animation. This guy's quite sad. So now we need a hungry animation. So hungry, this is going to be a little awkward, because how do you show that something is hungry? So I'm just going to do some mouth animation here. I'm going to click on record, and I'm going to increase the mouth size to like this. No, I don't want rotation. I want just the size to increase like this. So every time our pet's hungry, we'll see it by this really strange way. He's like gonna be like, oh, please give me food, give me food. And now we will have eating animations. So eat, I'm gonna change to 12 samples again. 12 samples allows you way more control, although it doesn't have enough. Like Unity interpolates a lot more of the animation for you, which is not a bad thing per se. So okay, we have eat. So for eating, again, the mouth is gonna do some movement. Actually, I'm gonna do a 3-frame real quick. Not that. I don't want rotation. I want it to be like this. I'm gonna move this a little down, and then I'm gonna move it a little up, and then at 9 frames I'm gonna move it a little down again, and then when it finishes I will restore the initial position, and you will see that it looks like he's eating. So that is the eating animation. The next thing that we will do here is, what is the other animation that we need? We need tired. So how do we show that this guy is tired? So we create a new animation, and we have the tired animation, and we will, when you're tired, you just try to lay down. So I'm gonna try to make him lay down by moving the hip bone or the neck bone, or whatever you want to call it, like that. Whoa, he's real tired. He's so tired. He's like freaking moving over here. Left ear effector. I'm gonna move this away from the ground so it looks like he's laying down, like rolling on the floor. And then we have this finishing with the initial pose, and we have please let me sleep. I'm sorry about that very loud car. that just went near my house. So yeah, that's exactly what's going to happen there. We're going to stop this recording, I mean the animation from playing. Please stop, it's weird. And so we have the animation set up, and now we have all these weird animation states. So what are these animation states? So we just have to organize them in a way that any state hits them all. So from any state, it will be moving to either of these depending on what trigger is set. So I'm going to move from any state here, make transition from any state to these guys, and I also want the idle. You probably can't see much, but I just did the transitions. You right click, make transition, and then connect with the thing. So also the entry state is of course being idle, and then any state, from any state, if we call another state, you can legally go, and then from any state you can also legally go to idle stopped. Idle stopped. So each transition, the way that these transitions work is that you right click and you connect, and that's fine. And you have the any state, which means from any state to this point you can go. And we have the idle stopped, which is the initial state. You have entry and you enter to idle stopped. So how do the transitions work? Well, the transitions have, each one of them has a, you can set a condition. So here it says conditions list is empty, so I'm gonna click, and for what's this, any state to happy, you can see on the top right, we can want the condition to be, of course, that they're happy. From any state to sad, we want to have the condition sad, and so on. We go for hungry, click here, then for eat, we add eat, and for tired, we add the tired functionality here. And in any state to idle stop, I want it to have exit time. So what does it mean that it has exit time? What it means is from wherever you're coming from, and you want to go to idle stop. What's up with this here or not? I don't know what's going on. If you want to go to idle stop, you only need to finish your animation. That is the whole premise. If you finish your animation, you can definitely go to idle stop, but to go to any of these, you don't need to finish the animation. So the animation can be interrupted. That's the whole point of this part. So if we go to idle, if we go to happy, you of course you can't see really any transitions here, but in game Unity calculates them correctly. So now we have all our transitions set, and we have our very simple pet controller set. We can definitely tell the pet whatever we want to do. The other thing that I want to do with the pet is some random movement. So what is random movement all about? So random movement is about us letting the pet just not be sitting here at the center of the screen the whole time. Well, I want it to move to the left, I want it to move to the right. So the way that you can do this, or that I can do this, I'm gonna actually save the prefab, don't forget. Go back here. What happened here? Why can't I save the prefab? So it says apply is grayed out. I'm gonna delete the prefab, maybe like this. Okay, I create a new prefab. That's fine. Okay, so we have a prefab called pet1 instead of pet. It doesn't matter. We can actually change the name of the object. And so what is really going on with this movement stuff? So basically what I want to do with the pet is I want to create a few anti-game objects, which I'm gonna call waypoints. This is just one way to do it. You can do it freely, but I like having the waypoints object. So that way I'm sure that my pet is gonna move wherever I want it to move. So each waypoint is gonna be placed on the screen at a different set point. So over here and all these points. And basically whenever the pet wants to move somewhere, can I do this? No. whenever the pet wants to move somewhere, it will decide on which waypoint to get. Well, the pet's not going to decide. Someone else is going to decide for the pet. But the pet is going to be told where to move. So basically, I'm going to create a public void. That's going to be called move. And I'm going to have nope. And I'm going to have a vector3 destination. And I'm going to have a private vector3 here called, of course, destination. And I will say this.destination equals destination. And that's my move function. And when we are, what we will do here is we'll have an update function. And we will say if transform that position is, or rather, so there's a functionality in Unity that's called distance. I'm going to measure the distance from my current position to the destination. If it's greater than whatever amount, like 0.2 or 0.5, we will use the move towards function to move smoothly to that point. So I also need a public float. I'm going to call it speed, so that we set what speed we're going to move to at, basically. Okay, so we go back here. So we're going to say if vector3 that distance, and so what's the distance? 0.5f. If vector3 dot distance from me, which is transform that position, to the destination, if our distance is more than 0.5, which means I am separated from that point by more than 0.5 units, which could be even 0.6, then I will do transform that position equals vector3 that move towards, and we're going to move, of course, towards the destination. And it also will ask, oh right, current is transform that position, destination is the destination, the target is the destination, and we also need the max distance delta, and this means the speed. So we have speed multiplied by time that delta time, and this way where any other script can set my destination, which will be based on my waypoints, and then we will be able to move to that destination with this function. So I'm actually going to do that right now. I'm going to be setting up the movement for the character, because I think that's very important to have already. It's one of the settings for a very basic pet controller. So we have the waypoints already, so we need another object. I'm going to call this object, I'm going to create an empty game object, and this empty game object is going to be called managers. So we will have a few objects, a few components that's going to manage everyone else. So what is this manager going to be called? This manager is going to be in my scripts folder, my managers folder, and it's going to be called, of course, I'm going to call it pet manager. So my pet manager is going to have a timer, and every time that timer is given up, if the pet is there, because maybe we're in the UI, we don't want the pet manager to be checking for a pet if the pet's not there. So here, pet manager, I'm gonna just do that. Pet manager is gonna have a reference, public pet controller, pet. It's gonna have a reference to the pet. I'm gonna wait until this allows. Oh, actually I also need something else. Public float pet move timer, and we also need a public transform array, and this transform array is going to be called waypoints. I'm going to be deleting all this stuff. I'm going to wait until the game loads so that I can set my waypoints and my pet and all that stuff here. So I'm going to drag my pet over here. Pet move timer, I maybe 0. No, I do 1.5 just test, and waypoints is empty, so I'm gonna lock this script on the top right to show you something, and we will select all the waypoints. Since it's locked, it will not change, so I'm gonna select all the waypoints, and I'm gonna drag them and drop them over here. You see that all my 8 waypoints are in the right spot, so that is wonderful. The pet will be moving correctly. So now that we have that, we save the scene, Control S, and we go ahead and what are we going to do with this? So we'll go ahead and do an update function, and then we'll also have a private void move pet to random waypoint. And so in update, we'll be reducing the timer. Oh, I also have to store the original timer. So original pet move timer. So actually the first thing is going onto awake, and I'll say that in my original pet move timer equals pet move timer, and then here we will have if pet move timer is more than 0, then pet move timer is going to be reduced every frame. It's going to be reduced every same frame with minus equals by time that delta time. But time that delta time is about 0.022, which multiplied by 60 should give a number very close to 1. So every second it's reduced by 1. So if pet move timer is more than 0, then we reduce it. But if it's less than 0, then we do move pet to a random waypoint, and we say that pet move timer should be equals to original pet move timer. So how we're going to move the pet? We're going to say pet.move, and we're going to move it to a destination. But what is the destination? We need to get a random number. So I'm going to do int random destination, or random waypoint, I guess that's the name of the function. So random waypoint equals, so what does it equal? It equals a random.range. And the way that we will decide what the range of the random is by just checking the waypoints array amount of waypoints. We do that by doing 0 to waypoints.length. So length will give you the array length of the waypoints array, and that way the game will choose every whatever amount of time which one of the waypoints to use to move the pet. So now pet.move, and we do waypoints, and we have the random waypoint variable right on top, right above, and it's complaining cannot convert. Oh, of course, that position. So the position of that waypoint, of the chosen waypoint, the chosen one basically. So that is what we will do to get this going. So let me just check that this works. We have the pet manager already set up. We have the speed of the pet. Oh, we don't have the speed of the pet. That's one thing that I must do for this testing part. So click on the pet, and I'm gonna add the speed. I'm gonna make it 50 just for kicks, just to check that it works or not. And I'm gonna click play and see what happens. So it's idle and it's moving, as you can see. Every 1.5 seconds, it will choose randomly one of those locations and move there. As you can see, it's way too fast. So I'm going to reduce the speed to 10. And also, it's way too often. So I'm going to reduce the timer, or increase the timer to be 4. So it's not too jarring. Oh, well, I broke it. Oh, there you go. I thought I broke it. You will see that every 4 seconds now it will be moving. If you choose the same waypoint that it's currently at, then of course it will not be moving. So the pet move timer, I'm going to increase it to be I don't even think 5, I think 7 is fair. And you can also of course do randomizing for this move timer so that it remains constant, but like the pet feels a little more alive. Being too consistent, it's not something that real alive creatures do. So I'm going to change the speed, as you saw, to, I think 10 is actually too high, so I'm going to change this to 7.5, and I'm going to apply my changes to my pet. And I could also have done like a move animation, but I don't really care enough. The other thing that is important is that the pet manager doesn't really move the pet while it's eating. So I'm going to do that in the next session because it makes no sense to do it in this session. So yeah, basically that's it. I'm going to do a small recap now of what was done in this session, and then we will end. Remember guys, you can ask me anything that you may need on the website, send me an email. I'm very active. If you need anything, I will definitely, absolutely give you a hand on anything you need. So what I did was I created a pet controller that only contains a few functions. One of them is moving, and the other ones are just for setting animations. And I created a pet manager that will, every a certain amount of time, move the pet, or tell the pet to please move to one random location that's calculated in the pet manager as well. And I also added a bone structure to my simulated very simple pet, and the pet has very nice animations, very nice animations created with 2D animation, the free asset, and 2D IK2. We have a happy animation. We have an animator that works with happy, sad, hungry, eat, tired, and idle. Simple animations, but this is the basics for a very simple pet controller, and we only did it in less than an hour, which is awesome. So thank you guys for watching. I'll be right back with session 2.2, which is needs and satisfaction. Hello everyone, welcome back to how to create a virtual pet game in Unity. This is Ramon, and I'm back with session 2.2, which is needs and satisfaction. As you can see, we already have a little pet setup over here, and this guy is able to animate in several ways. We can check out the we can click on it and we can see that he has the happy animation, the sad animation, the eat animation, and the tired animation, the hungry animation, and also the idle animation. Any animation that he plays, he will play, and then he will move to the next animation without any issue, any sort of problem. Also, this pet moves around on the scene with no issue either, because he chooses randomly every certain amount of time. We can see here the time on the controller. Every 7.5 seconds he decides, I don't know how long it takes, but every certain amount of time he decides where to go on a random basis between the waypoints that I set previously on the previous tutorial. So if you haven't checked that out, you probably will want to for the basics of this guy. So let me pause this animations, and so now we have to create what I like to call needs. So what is a need? A need is one of those things that you can see in the old school Tamagotchi, where you have how hungry they are, and how happy they are, and how much energy they have. So we have to create a needs controller that will let us know how much of those things the creature has, right? So what do we need for that? Well, the first thing is we need a controller, of course, as I just mentioned. We need a needs controller. So I'm gonna create a new C# script, and I'm gonna call it a need. Well, I want all the needs to work on a global scale. I don't want each of them to have a different sort of timer or anything. So that way we can control very precisely when the pet's hunger, when the pet's gonna get more hungry, when the pet's gonna get more thirsty. It's gonna lose energy, it's gonna get a little more unhappy. So I'm gonna create a new C# script, and I'm gonna call it a timing manager. My timing manager, I'm gonna go into that first because it's important. So we wait a little bit until the Unity, the Visual Studio thing loads. I'm gonna delete this, and I'm gonna show you this. So the first thing that we need is a public float game hour, and so a game hour is going to be set. Actually, it's going to be a public static float so that anyone can read when the game hour is passing. So this public static float will define how it works for this for every hour, when every hour passes. So when we're in real life, an hour will be 60 minutes, but if we're testing or for balance, we want to change the length of an hour to be seconds or minutes at most. So I'm gonna go ahead and set a public float hour timer so that we can set the hour timer on the inspector. And now we're gonna go to update, and game hour is my my actual timer, and this is not actually a timer, this is the length. So we're gonna say if game hour timer is less than 0 or less or equals than 0, then we will do something real cute, that is hour length, game hour timer equals hour length, right? And then else, if it's not less than 0, then we will say that the game hour timer is going to be reduced by time.delta time. And as I explained before, time.delta time is a variable that is set in the inspector, and it usually is worth, or at least the default is worth like 0.022, so that if you multiply by 60, which is 60 frames per second, you get a full second, right? Okay, so that is our game hour timer reduction, right? Now we can go to a pet controller and we see that this guy, okay, no, never mind, that's fine. This is completely fine. Distance and stuff, pet manager. Pet manager has a timer. So do we want to move it according to the hour, the in-game hour? Not really. Why? Well, I want the in-game hour to work mostly for balance purposes, and moving a pet here and there doesn't have anything to do with balance. So I'm going to go back to my timing manager. We can see that this is basically complete. We have game hour timer, we have an hour length, and this guy is going to be moving the time down every time a frame passes. So we can actually stop using those, and we have a full script that is a timing manager. Now I'm gonna go to my pet, to my needs controller. Okay, so now we have to load the needs controller script, and we'll delete this. And now we have access to our needs controller. So what are the needs of my pet? So the first thing that we know is that our pet must have hunger, which is an int hunger. We have an int happiness, and we have an int energy. So how are we gonna treat these guys in the code? So basically, when we have to go to update, and every time the game hour is depleted, we will reduce these guys by a certain amount. So I'm going to create a certain amount of voids, which are going to be public. So I'm going to do public void get hungry, or rather add hunger, and we're going to add int hunger, or rather amount. So there's an issue that I found out when I was making my first Tamagotchi. The naming convention in Tamagotchi is really weird. Why? Well, basically, if you check out the Tamagotchi example again, you will notice that we have these confusing terms. We have hunger, we have happiness, and we have energy. So hunger should be actually called food, because the less food, the worse. The less happiness, the worse. The less energy, the worse. So we're gonna rename hunger to be food. So we create this food, and now we know that the more food there is, the worse, the better. So whenever we add hunger, we are adding something bad. So we are reducing food. So food minus equals amount, which makes a lot of sense. Then we will also have something else. We'll have a public void. I'm actually gonna change the name of this to be change food, so that we can vary it up and down. Instead of being add hunger, which is only down, we have change food, which is changing the food amount by a set number. So it could be negative or positive. So now public void change happiness is going to also take in an int amount. And now what I will do is I will say that happiness plus equals amount, which is fine. Now we will add a third void, and this is gonna be, of course, change energy. And this is gonna be changed by int amount. Remember this prototyping phase, we can vary stuff as much as we want depending on the progress of the code. So maybe I'll move this void somewhere else or something. I mean, I don't think so, because this makes sense, but it's always possible. It's not always an option in this sort of you know, prototype coding. So we have food, happiness, and although I do plan this, but whatever. So happiness and energy. So what happens with my food, happiness, and energy? Where do we start? Where do they start? So we don't know where they start, right? So I'm gonna create a public void. I'm gonna actually create a public void initialize, and of course I'm gonna take an int food, happiness, and finally an int energy. So with these ints, I will initialize my values. So basically what I'm gonna do is I'm gonna have food be equals, this dot food is gonna be equals to the food that someone is passing in the future. This dot happiness equals, you know, the same thing. And then finally we have this dot energy, which is gonna be taking in the energy value from whoever's coming with this. So so in void update we will say if timing manager the timer, which is game hour timer, is less than 0, we will change everything. Food by a certain amount, we will change happiness by a certain amount, and we will change energy by a certain amount. So why do I not pass in the amounts? Well, I want a variable that's called tick value, so that every time the hour passes, there's a certain amount that I am gonna correct if needed. Not necessarily in this prototype, but if you need to change the food, like if you have less than 50, you want it to be higher, the amount of food that's taken from the player is higher, then you can do it. So I'm gonna create a public value that's gonna be a public int food tick rate, happiness tick rate, and finally energy tick rate. And now we're going to be changing this by minus food tick rate. So food tick rate has to be positive. Happiness, rather minus happiness tick rate, and then at the end we will add a minus energy tick rate. So the other thing that you can do with this is, like, if you have a character that's older, maybe you want it to have more hunger, like get hungry faster, or something similar, like you want variations on the behavior of your creature so that it feels like the creature is more alive. You know, it's very important to have stuff like that in your game. So now we have this timer part thing. We need to check that it works. So since we can add our timings, our needs manager to this guy. I will add it right now. I'm gonna go ahead and add a timings manager, a needs controller to my pet. My food, I'm gonna initialize in a second. And my managers, I will add my needs manager, my timing manager to this guy, and I will set the hour to be 10 long, basically. Okay, so the other thing that I want is, of course, I want a UI that shows me the values of the food, the values of the happiness, the values of the happiness. But actually, right now, I will not do that because that's part of session 3.1, UI creation, hooking up. So we have the needs. I'm gonna hit play here. Well, not really. There's another thing that's important here. We don't want the food to go below a certain amount, but also we want to have a way that something has to happen if the player hasn't fed the pet for a while. So we're gonna go into pet manager, and we will create a new function. And I'm gonna create this function. It's gonna be a public void die. So there could be there are a certain amount of reasons of why the pet is dying, right? So it could die from hunger, it could die from happiness, it could die from low energy. But we will not really differentiate that yet. Or yeah, we will not do differentiation. So we're just gonna go ahead, and the pet manager not necessarily has to be a global, but this function should definitely be global. So I'm gonna go do a public static void die. I'm gonna go to my needs controller, and I'm gonna say if food is less than 0, then I'm gonna go for my pet manager, pet manager, and I'm gonna say die, whatever that function does, because it's not implemented yet, but that is the whole point. So if we have less than 0 of any of these, then the pet will die. As you can see, I made a mistake. I should have copied the whole if block. So if happiness is less than 0, or if energy is less than 0, then our character will die. And the other thing is we can't go over a certain amount. So we don't want the player to be able to feed the pet as much as they want. So we will say else if food is more than 100, then food is equals to 100. We will do the same thing with happiness. So we can just copy this else if block here, and we change the name from food to happiness. And finally, we can paste it here too, and we're gonna change energy. Nope. Energy. There we go. So this is the, I'm just gonna hit play here. I should be able to see my values over here. We can see that we have food, happiness, energy, tick rate. So I'm gonna be changing this value to be 100, or rather 100, 100, and food tick rate, I'm gonna set it to be 10, 10, and 10. So we can see change. Now I'm gonna hit play and see how this works. We'll see that every 10 seconds, this should go lower. This should like pop down or not. Why is it not going down? Oh, there you go, it went down, 90, 90, 90. So every 10 seconds, these values are gonna go down by the tick rate that I already set over here. You can see that it's 80, and as such, that is a good start. So we have the lowering of these guys. So the problem with the initialization in this tutorial, in this video, is that this initialization is going to happen in 2.3, not now. So we're going to leave this behind. That's why I added the values on this part. I'm going to hit apply here actually. I'm going to hit apply. There we go. Okay, so now that we have that, the next step is to satisfy our needs. So how do we satisfy our needs? Well, basically, we have the public void change food over here, the public void change happiness, but we need someone who is able, some script who is able to access this. And that's basically like a UI thing. So what I'm gonna be doing is basically just waiting. This is gonna happen, the satisfaction is gonna be happening on the tutorial about user interface. It's not gonna happen on this one because this one's purely about the needs and the satisfaction. That's covered on this part. So what does this entail? What does this mean? This means that we will need to set up a script later that accesses this script and changes the values, but it will all depend on the way that UI is implemented and stuff. But of course, we don't want the controller to be accessed. We want the manager to talk to the controller. So we have the pet controller pet here, but we will add a needs controller, I suppose, which is, obvious. We want the needs controller for our pet to be added to our pet manager so that we can change, of course, the values through the pet manager. So in that case, we can remove this public static void die, and we can make the pet manager himself an instance. So I'm going to explain public static pet manager. I'm going to explain what this means in a second. In awake, we say if instance is null, then instance is this. This is not the best coding. Debug.log more than one pet manager in the scene. So I'm gonna actually log a warning. So what happens here? What's this about? So what this allows, when you do a public static, as you saw before, as you saw with the timing manager, this is a public static, and I had the public static void die. Basically what will happen is, I'm gonna actually do something here later, but what will happen is whenever anyone needs something from the pet manager, they can access this one pet manager, the one pet manager that I have over here. There, it's complaining. So the one pet manager that I have over here, this pet manager, this very object, not any other object, will be the only one in the scene, and thus we can make sure that this is accessed from anywhere that we need a pet manager. Though we need the pet manager's functions. Otherwise, we will have to like find the object or other kind of stuff like that. Now, this is usually frowned upon. So if you're going to build like a massive game, you probably will want to avoid this or implement some sort of event system. But for prototyping, like for quick idea confirmation, so for confirming that your idea is able, like you can do this idea, you can definitely use the instance approach, which is the way that I like to call it. So now that this guy is an instance, you can see that this script is complaining. It says an object reference is required to access non-static member pet manager.die. We can see here that all of these guys are complaining. So the way that you actually access this is by doing pet manager.instance.die, and that way you are accessing that instance that you are setting. The one thing that you have to be careful about is to not access that instance in awake, because of course you are setting it in awake. So everyone's awakes happens at the same time, and some awakes will happen before other awakes, because of course that's the way coding works. You're saying, hey, please in awake do this, but there's 100 scripts whose awake is going to happen first. You don't know. So if you're going to access this guy from any other place, you should do it after awake, and whatever happens after awake is update, start, or unenable, or any void that you may set up. But yeah, it has to be start, update, unenable, or any other script, any other place, but never on awake. Awake is the first thing that happens. You don't want to have what they like to call race conditions. So of course, let's move on to the next thing. So I'm gonna actually, whenever they die, I'm gonna be a debug.log dead, and we're gonna go back here and see that we have no errors, hopefully, and we'll test the death function because I want to make sure that it works. So that's why the hour length is very important. So I can go ahead and change my hour length to be 2, so I know that in 20 seconds my pet will have all this stuff depleted. So I'm gonna save the scene, and I'm gonna hit play, and we know that every 2 seconds this should go down. There we go, 1 tick, 2 ticks, 3 ticks. We can also increase the tick rate if you want, so we can do this so that it dies from food, from starvation. It's dying from starvation very consistently, and I'm gonna wait a little bit more so that it dies from the other 2 sources too. We can see that the number is gonna start hiking here. Yeah, there you go. Also, it's 3, of course, 3 sources for the dead thing. It's coming from change happiness. It's coming from change energy. You can read it down here. And it's also coming from change food. So it's very important. That's a very important thing to have over here. So that is the way that death will work in our game. Anytime the pet's values go down below a certain amount, they will call the pet manager to kill the pet, or maybe to show some sort of defeat screen or something. So I'm gonna hit Control A, then K, then F, then then S, so that we can set up our spacing over here. It's set up automatically. It's very nice. Okay, so the next thing that I want to do before moving on, so that's basically it for needs and satisfaction. So needs are set up, we have the timing, we have the needs themselves, which is all good. basically time passing and fixes is gonna be a little heavier. But the next thing that I want is to have a little background over here. I want to have a background for my pet. So I'm gonna check my art. I'm gonna go to pets pack, PNG, or rather it says screen. Oh no, that doesn't work. So pack PNG. This doesn't work. I might want to get. I'm gonna go to the asset store and I'm gonna find a little a very small background for our pet. So I'm gonna go get a 2D background. Okay, so I'm gonna reduce my price to 0, of course, because we're poor. So we have this asset over here. This looks pretty nice, hand painted. Now I like this free 2D beach. This works. Okay, so I'm gonna be downloading free 2D adventure beach background from Super Brutal Assets. That's a very interesting name. So now that I downloaded it, I will hit import. And I only want the night background. I actually want the day and the night, not sunset. Now I'm gonna import, and I will create an object in my scene that carries this background after they're all loaded, of course. Okay, so we go ahead into free 2D background. We will move this. Actually, we'll move there's two things. I'm gonna move the free 2D adventure to art. I'm gonna move the pet pack to art 2. We want the resources art to be all in the same folder. Don't make a mess of your game. So we have free 2D adventure, day backgrounds, and I will be adding the beach sky. Pretty nice. I will put it like over here so that it looks cool. Now the wave, I have to add the wave 2. I will increase the ordering layer of the wave to 1, and of course the pegs ordering layer has to be increased to like 5 so that it's never behind anything. So we move the wave down. We have the C part of the thing. Let me see how that looks on the scene. Okay, and now we want the mountain also. We want some mountains behind our character so that this actually looks like a nice beach thing. So we add the mountain over here. I'm gonna flip it on X so that we can create a very simple and nice background for our scene. So that works. I'm gonna create another clone. I'm gonna put it in the center, and I'm gonna actually send it like to the back. I'm gonna make the background itself to be -1 so that everything's in front of it. And we have this guy. I'm gonna flip it on X so that it looks a little more realistic-ish. I'm gonna move this to the left again. This one I'm gonna flip it again so that we have a team of things behind our little guy. And I might make my pet smaller later, but for now I think it looks fine. It's a pig that lives at the sea. And then we will create an empty game object that we're gonna be called background. And I'm gonna accumulate all these guys. I'm gonna move it here, and I'm gonna change this name to background, like back. This is gonna be middle. The C is gonna be middle back, and all these mountains are gonna be in the back too, but it will be well, I guess the middle. This is the front. This is the middle. And all the mountains are middle back. So this way, middle back. If we want to substitute our backgrounds, we can do it by code. And I'm gonna actually show you how. I have time on this one. So the way that this will be done is by adding a new script. And I'm gonna call this guy, I'm gonna go to my scripts. It's gonna be a controller. I'm gonna create a background controller. The background controller can take care of many things. Controller. So the background controller can take care of many things, and it could be like moving the backgrounds, like adding animations and so things like that. But I'm gonna add it here. Background controller. Control AKF, we delete this, and I'm gonna have a public sprite. What we're gonna do is gonna have a collection, public sprite array. I'm gonna call it backs. We're gonna have another sprite array, it's gonna be called middles, and then middle backs, and finally we want, what else? Oh, that's it. Okay, so we have this, and we can have a public void randomize background, and what this is going to do is it's just going to create a random number, so it's going to be int random. So we also need a public sprite renderer array, which is going to be our back renderer, it's going to be our middles renderer, and our middle backs render, middle backs renderers. So we're gonna have an int random choice or random background, which is gonna be equals to 0 initially, and we're gonna create a well, rather I'm gonna create a private int random. No, I'm not gonna do that. So what are we gonna do with this? So the first thing that we will do is I'm gonna add the ton of sprite renderers here. So we have the back renderer is this guy, the middles renderer is this guy, we have the middle back, there's another middle renderer over here which is this guy, we have the middle backs which is 3 guys there, 3, and we have 1 back. So now we have the middle backs. So what are the middle backs? The middle backs are the mountains, at least in my example. So I'm gonna go ahead and add a few of those assets, resources, art, 2D, day backgrounds, and we have the middle backs. So we will play around with that. So we're gonna the middle backs are gonna be this guy and some of the clouds. And for the middles, we have this, the beach mountain 1, apparently it's a middle, that's wrong, actually. This is actually a middle back. So that's what I thought before. So this is a middle back, and this is, I'm gonna delete the array element. You right click on element 0 and you do delete array element. So you can do it, you actually have to do it twice for it to be deleted. And then after this, what I'll be doing is, okay, we have all our stuff, we need more of these though. So this is my middle backs, we need my middles. My middle is the sea and my front is the wave. So I forgot to add fronts here, and we also have to add front renderers here. I don't know why I added this, but I do know I got confused there. So this is just a randomizing background tutorials, I guess adding it to the tutorial series because I needed to add something else. I just wanted to add more stuff. Okay, so we have the middles. What are the middles? The middles are the oceans, this guy over here, and the backs are the beach guy. There we go. We need the front, which is this guy over here, the wave. Alright, now that we have that, we also need the front renderer here, which is this guy. We're just dragging and dropping, so we make sure that everything's in order. I'm gonna actually seal this guy so we can go back to the night backgrounds and do the same thing. So we have the night beach sky, we have the night beach mountain as a middle back, the clouds too. Oh, I was gonna do the same thing twice. So this is a middle back, this is a middle back. Night wave 1 is gonna be my front, and then we have the night sea as a middle. And now we have all that set up. We have our randomized background function. So what is the randomized background function? We will say that sprite renderer, back renderer. So they're all arrays. these guys are all arrays. So what we'll do is do a for each sprite renderer sprite in back renderer, for example. This is going to be systematically done in a second. We will say no, we have to pick a random one in this to set as my back. So rather a random one in this, by yeah, you get what I mean. So for each sprite render in back renderer, we'll do sprite. This actually should be sprite renderer in back renderer, sprite renderer, that sprite equals backs, and then for choosing which back we're going to use, we're going to use the random functions. I'm going to say random.range from 0 to backs.length, and that way we'll get a random number that's going to go from 0 to the number of back graphics that we have. So it's going to be going in this case from 0 to 1, so it's only 2. And how do we know that's going to go from 0 to 1? Because the length is 2. So these random functions knows that we want from 0 to 1, so this subtracts 1 from the top number. So you can see here it says returns a random integer number between minimum inclusive and maximum exclusive, which means the maximum number is not used. So what's the strength in this? Well, the strength is you would have a randomized background real easy, but we could make the mistake of just doing this, one for each of them, and that is not what we have to do. What you should do is create a new function. So I'm going to create a private void choose graphic for renderer, and we add a for renderers we add a sprite renderer array renderers, exactly, and then we add a sprite array sprites, and then we copy this for each loop and we put it here. And now we have our sprite renderer, but it's not going to be back renderer. This is going to be sprite renderers, and this is going to be back. That is going to be sprites. This is a way to generalize sprites, and this is going to be sprites. This is a way to make your code a little more generic so that you can use it in more things. So that way we're not going to be writing this for these 3 lines every single time. We will just be doing choose graphic for renderers a bunch of times. So we do backs, so we need the sprite renderers first, so it's a back renderer, and we'll add the backs, which is the sprites. Then we do choose graphic for renderers. Also, it makes your code clearer, so whenever whoever reads this, they know that you're trying to do this randomizing thing with your code, instead of just randomly, what is this, thinking like what's this thing. Okay, so we're gonna go do middles renderers. There you go. With middles, of course, we'll have to make sure that we're doing the right call to our functionality here. So middle backs renderers, and we have the middle backs here. There we go. Then we will call front renderers, and we add our front here. So we have the back, middle, back, and front. That is all that we need. Just that, this looks like it's larger just because the names are longer. So just don't be fooled about that. Don't be fooled by that's what I mean. So when is the randomize happening? So I'm gonna go do start, and I'm gonna go randomize my background so that it looks randomized every single time. My background is never gonna be the same. So we wait a little bit. Now we hit play. We expect it to be random. So we have the 2 clouds over here, and they are where they should be. They're just clouds, and that is a completely randomly generated background. So I'm gonna check. Okay, so you can see that the sprites are very spread because of the position that I chose, right? So I'm gonna just move this guy a little more inward so that we can see them. Instead of just having two backgrounds, we'll have a little more, I guess, a fuller background. Yeah, you can see here that looks way better. I still think that one of them is not visible. I'm just being silly, I guess. Oh, that's it, the cloud looks longer. So we have a pretty nice starry sky with some randomly placed clouds, randomly chosen clouds basically. So they are already placed. We have a mountain now with a little cloud coming from behind. It's really romantic and stuff. So that looks way better than just me having a static background. Here we can add some interesting stuff to the player, for the player. And we can see that now we have 3 blue mountains and 1 white mountain. It looks really nice. Actually, I really like the way that this came out. So I'm gonna do a small recap now, and you guys have any questions, please ask. I am, I'm available through email, through the website, through messages. So if you guys have any questions, just ask me. All right. So what happened here? Well, what did we do? We added 2 things to our pet. We added a needs controller, which is gonna be keeping track of the needs, keeping track of the hunger, of the food amount, of the happiness amount, of the energy amount. This guy has the functions to heal those and to to hurt them. Basically, if they were health, that's the way that you would define it, right? So we also added a timing manager that has a global timer that will be called, but will be listened to by anyone who needs to know when the game hour is passed. We don't know yet. But for now, the needs controller is the only one who cares about it, and it will be changing the food depending on the tick rate that we set over here. For our our different needs. If you level up the creature, if the creature is older or younger, you can change the tick rate. Maybe you want it to be like hungry faster, but happy slower, and the energy can change. Actually, we can. I'm gonna add this right now, so we can add an int food tick rate, happiness tick rate, and energy tick rate. This is like a post-credit scene, right? So this dot food tick rate equals food tick rate, and then this happiness tick rate equals happiness tick rate, and finally this dot energy tick rate equals energy tick rate. And okay, so now we have this. Anytime the pet is initialized, we are deciding which food tick rate, happiness tick rate, and energy tick rate is going to be happening. Of course, you don't want like the energy to go down too fast. Maybe actually that the energy goes up. So you have to design around some sort of balance that you want in your pet. I'm gonna go to my pet manager. Oh no, yeah, we're not initializing this yet because that's gonna happen in the next video. The next video is gonna be all about saving the data from the pet and then analyzing it when it's loaded, which is a little complicated and it will take a little bit to find. Continue on in just a second with session 2.3, time passing and fixes, which is all about saving, loading, and analyzing data from our pet. See you later. Alright everyone, welcome back to how to create a virtual pet game in Unity. This is session 2.3, time passing and fixes. So we have created a pet which develops needs basically. So it's we have a little issue with that. So basically our needs are never initialized. So we never know when we start the game, when the player starts the game, they never know. Like the pet skull was gonna start at the same exact point, and that's not fun. Fun of the Tamagotchi is being also we have backgrounds that change. The fun of the mini game of a game of Tamagotchi is that you have to leave it and be able to come back, and the Tamagotchi will be at the exact same state. So what we're gonna do is gonna be creating an object called a data manager, and this data manager is gonna take care of saving and loading data from the pet. But the first thing that we need to do for that is we need to create an abstract script that's going to be called a pet. So I'm gonna create a C# script, and I'm gonna create just a pet, just that pet. So what is the pet going to be about? What is it going to contain? For this tutorial series, we don't have, well, the first thing we have to do is this and all of that stuff. So for this tutorial series, we don't have a, let's say, a need to name the pet or to do stuff that is very obvious. But the one thing that we need to do is we need to know when was the pet last fed. So how do we know that? Well, every time the pet is fed, or the needs change, not necessarily when it was fed. Well, yeah, it has to be when it's fed. So whenever the pet is fed, or the happiness changes upward, or the energy changes upward, we have to store the information of the moment when that happened. So how do we change that information? So the first thing that we should do is in here in the pet, we will store date time. So as you can see, we cannot access what a date time is, so we're gonna add whatever Visual Studio suggests that we should add. In this case, it's using system. So using system, we're gonna add date time. So I'm gonna have a public date time, and we're gonna call this the last time fed. Then we're gonna create well, we can continue in this same line, and we will say not just last time fed, we'll say last time happy, and then last time gain energy, I guess. Gain energy, or energized. Gain energy is better. Okay, so the last time that these things happen are gonna be stored in my pet. The other thing that we need is a public int food. We need the three needs. We need the food, happiness, and energy. So we need food, happiness, energy. And that's basically the data that the pet should hold, at least for now. So we will go ahead and go click here, and then we click on this little screwdriver, say generate constructor, and we select all of them, and we'll hit OK. So we will see the list of things. We'll see that we have a date time, we have 3 date times, we have 3 of these things. So how do we save this information? So we're going to save this information by using JSON. JSON is a little text file that you can generate very easily in Unity. The less amount of data that this file has, the faster that it gets generated. So I'm going to try 2 approaches. Well, I'm going to try the first approach. If the first approach works, we will not do the second approach. So the way the first approach should work is every time the pet changes anytime the pet changes any of these, then we create a new pet and we save the file. We overwrite the file every single time. So that is what we're going to do. We're going to do a pet that every whatever amount of seconds that anything changes, let's say every time the hour passes, it will save the current information, or maybe the last information instead of the current one, because of course whenever the time changes, and whenever the hour changes, that's when everything will be reduced. This needs controller is going to be reducing the stuff at that time, which means the data manager will not be able to catch up at the same time. So the data manager is going to be auto-saving the last state, and every time, unless we change it upward. So if we change this, the last time fed, happy, or energy positive upward, so we will definitely save at that point. But if it's because of the hour ended, then we'll save the last state, which in itself may look a little contradicting, but it is a good way to design the save system so that it doesn't overwrite every 10 seconds, saving things all the time. So let's go ahead and I'm gonna check that the audio is working fine, which it is. Great. Okay, so we will go ahead and create our data manager right now. I'm gonna wait until Unity reacts to my changes. So the first thing that I'm going to create is a database object here in the abstract. So because why abstract? Well, I don't need many things for my database. So the only thing that I need is a public void save data, and I need the save path. So I'm gonna do a string path, or rather a save name. So save name, I don't need the path because I know where I want to save it. And then what else do we need? We need the object that we're going to save. So we have to add a type here. So like this. Okay, so then we need the object that we're gonna save. So t, or rather string file. Is this correct? I don't remember. Okay, so no, save data. So if this works the way that I think it should, what's going to be happening here is I'm saying so you can save any data of any type. I don't know the type of the save, so what we need is a save name and the data, which is just going to be saving this data into JSON wherever wherever I want it. So I know where I want it. Where do I want it? I'm gonna create a folder for my save. So I'm gonna go to resources, and I'm gonna right click and create a new folder. It's gonna be called saves. So in here is where I'm gonna be saving my data for my game. So I'm gonna be saying JSON utility dot to JSON, and we have the type T that we already have up here, or rather save data. Oh, wait. So to JSON, and we have the save data object. Yeah, that's it. So this generates a string. So I'm gonna, of course, create a new string here. It's gonna be called JSON to save. It's gonna be equals to that stuff, which is good. And then we need to save it somewhere. So we're gonna say JSON utility dot, or rather file that write. As you can see, we cannot access this always. So we're gonna have to, using system.io, we'll say file that write all lines, and the path is, I'm gonna actually write down the path over here. Private string path equals, this path equals application that data path plus resources. Save data saves. I think that's the way it works. So we have resources and saves. That's my path plus the save name.json, of course. So we're gonna be doing this path plus save name plus that JSON, like that. And now the contents, of course, as you can guess, is the JSON to save. And that is my, what? Cannot convert from string to string. So write all text, I guess. Yeah, so it's write all text, which takes a string path and the content. So this is going to be saving my stuff from there. And then the public, this is the saving. So for saving, we need a save name and a type save data. And that will write the file to my folder that I'm choosing with the name that I'm choosing with .json, because it's a JSON file, right? So then we will do a public void load data, or rather public t load data. What are you complaining about? Generate class t. Oh, we cannot do public t. Okay, so public void load data type, and we're gonna say string save name Okay, so what was he complaining about? So I'm gonna do a little research here. Okay, so we're gonna be checking this should be fine, I think. So what I'm gonna be doing here is I'm gonna be requesting callback. So I'm gonna do system.action of t callback. So this t has to be the same as this t, and this callback is going to be giving me the save data. So I'm gonna be asking, please load this data from this file, and then this format, this thing is gonna be giving me the data back. So I'm gonna say if file.exists, and what is the file? The file that should exist is this, the same path plus save name plus JSON. Then we will do a t loaded JSON is equals JSON utility dot from JSON. Whoops. From JSON, and we're gonna of course convert to the type that we want. We've been working with the same type. We don't know what the type is. The whole point is to make this so that any type can work, but we want the pet type. So from JSON, and the string is, the JSON is of course file.read all text. Well, you know what? I'm just gonna load it like this. I'm gonna say file.read all text path plus save name plus the JSON string JSON loaded JSON equals. So we have the file here, and instead of doing this, we will say callback JSON utility from JSON loaded JSON. Else debug.log file doesn't exist. Okay, so what is happening here? So what we're doing, this is, as you can see, this is like quite simple. It just takes a little thinking. So we're saving. To save, we're saving the type that we're requesting, which is going to be pet. You will see that in a second when we write the other stuff. Actually, I'm going to add this here. Okay, so then we save to a file with the name path plus the save name plus to .json, of course, period JSON, so that we add the typing so that Windows can understand it and Unity can understand it, of course. We're writing this file. So after we write the file, we load the file, and we still don't know the type. So if you're gonna load a certain type of file, you have to make sure that the file, the JSON that you're loading, is compatible with that type, which we are, because it's the only JSON that we're going to use. But if you have many saved files, saved types of files, then you might not want to do it like so. So we have the string loaded JSON, which is equals to file that read all text path plus the save name plus to the JSON thingy. And now we do the callback. The callback is going to send the file, the type, the file converted to a type, which is going to be the pet, to whoever calls this with this callback. So we're going to check out how that works. So now we go now we have our database guy. We're going to be going to the scripts, of course, after this is done. Scripts and managers, and we're going to create a new manager, and it's going to be called a database manager. I'm going to load this bad boy, and the database manager, of course, will have a public function, a public static function, void, and this is going to be load data. Or rather, I'm going to make it an instance the same way that I made it an instance with the pet manager. I'm going to do the same procedure that I did here. I'm just going to save this part. Then I'm going to go to database manager. I'm going to say public static. So this is, what does this do? The whole point is to have all the saving stuff in one script, so that all other scripts can go ahead and ask, hey, please save this for me. Yeah, thank you. So database manager instance, and then in awake we do what I explained before. It's the exact same thing. You just have to change the name to database manager. Okay, so now that we have that, we need a public void here. Well, we need a private database, and we're gonna call it database, and in await we'll say database equals a new database. So this way we can use that guy. So public void save, and then we'll have a public void load. Nope, no, not like that. There you go. Just load. And in load, what I do want, actually I'm gonna not have this as a void, I'm gonna have this as a pet. So load pet is gonna be the right name, pet, and we're gonna be taking in a pet over here, so we can save something, of course. So simply we'll do database.save data. The type of the data is asked for us. So the type is pet, and the save name, I'm gonna call it 1, and I'm gonna call it pet, and the save data is gonna be called pet. So we're just naming everything pet. You can see that its complaining name can be simplified. We can just delete that part because it's obvious that this guy is a pet. So why, Unity, or rather the C# can understand the logic that we're trying to do. What about for loading? Well, for loading our pet, we just do database.load data, and again it will ask for a type at the start, and it probably just not take it later. So the save name is, I'm sorry, I forgot about this, pet, and the save name is pet, and the callback is return no, rather I will do this thing over here. I'm gonna do this guy. I'm gonna explain right now what a lambda expression is. It should work with a lambda expression. So I'm gonna call this pet. Return pet. No. Another function converted to a void returning delegate cannot return a value. Pet equals pet. Okay, so I got it. Pet return value equals no. I'm gonna change this to return value, and then we return value. Okay, so how does this work? Well, the first thing we have is we have to create a pet to return, even if it's null. So we create a pet to return. It's a null pet, doesn't have any data, and then we return that value. In between that, we will check with the database. Hey database, try to load this pet with the name pet, that it should be saved in our folder. If you find it, then just assign it here. Just assign to our return value that pet. The lambda expression works depending on the type. So we know that we created a callback. When I go here, we create a callback here, and that callback we're doing it through a lambda expression with, in parentheses, we assign a name to the pet that's being returned here. We do callback returning this JSON utility thing, and then we just return that value. This might not work correctly. I might have to do an enumerator, but I do hope that it works. So how are we gonna check, of course, how are we gonna check that it works? So I'm gonna go ahead and say, in start, I'm gonna try to load pet. And actually I'm gonna do something called a debug.log load pet dot energy, just to say something, right? Just to say something. I'm gonna try to load these pets energy. That way we will, have something to be working with here. But this is only if the load pet is not null. So pet equals load pet, and we will say if pet is not null, then we will do this thing. So it's already chained together. We know that if pet is null, then we will not try to debug.log the energy. So the first time that we run this, of course, it's not gonna be doing much. So, as I mentioned before, when do I want to save my pet? I want to save my pet whenever the timer goes down. So the first thing that I will do over here is I'm gonna create a public needs controller, and I'm gonna grab this needs controller that we have over there and add it to my manager, to my database manager. This is again prototype type of coding. You probably don't want to tie together your needs controller to your manager. You probably want to like generate different types of pet, but this is like the core part of any pet simulator. So we're gonna add the database manager here, and we're gonna add the needs controller here. Right, which is great. And I'm gonna create an update loop here, and we'll say if our friend the timing manager that our game hour timer is less than 0, then we will save that frame. We will save, I guess, once. So we'll do save pet. We have to create a new pet. So we're gonna say pet equals new pet. And you will see that it was gonna complain because it wants all the stuff, all the data, which we don't have, at least not yet. So why do we not have it? Because our needs controller does not keep track of when it's feeding. So I'm gonna have to add a public datetime. As you can see, it's not available. We have to add system. So we're gonna add a public datetime, and we're gonna use the same names that we have in our pet. We have this exact same naming convention for our needs controller. We don't want to just go crazy with that. So last time fed, last time happy, last time gain energy. Every time we initialize this pet, we will say we'll need these values. We'll need a date time for each of those things. So I'm gonna go, actually the pet has a great this thing. Oh no, I'm wrong. So what we'll do is we will say this that last time fed equals date time that now. Then well, we don't need this. Then last time happy equals date time that now. And then we have last time game energy equals date time that now. So that is the way that we'll be initializing our pet if it's not initialized. Then I'm gonna copy last time fed. So if food is, okay, so that's cool. But if amount is more than 0, then this is gonna happen. And then we copy this and we do it for happiness. We're just setting the last time fed, last time happy, and the last time gain energy for each of these. As I said, every time it's positive, then we will save that, and our pet will have that data. So we're gonna go back to the database manager. As you can see, we don't really have like the data yet. So how do we get the data? Well, as you can guess it, our needs controller is gonna have the data that we need. So we have the needs controller for each of these things. We need the, this is, you can see it says last time fed, happy, gain energy. So this is happy and this is energy. There we go. So we need the needs controller food, needs controller happiness, and the needs controller energy. That's exactly the data that we need. So we have this thing, and we're gonna say save pet. Now we have a pet that we are trying to save in that frame. Okay, so next thing that we're going to do is check that this is actually saving. Oh well, there's actually no way that we check yet because we don't have a UI and this is not the UI session. But I guess I could create a UI for it anyway. So yeah, I will do that. Okay, so we're gonna check with saving through a very simple UI. Just a very simple UI, I suppose. I didn't want to do that yet, but well. Okay, so UI, I'm gonna create a button. And this button is, I'm gonna only do it with feed, just so that we don't have that many things. So we go to pet, change this to needs controller, and we add change food, and we will add 10 food. Now, I'm sure that this will get saved, so I'm gonna go to saves, and this folder is empty. We can refresh, and you will see that it's indeed quite empty. Okay, so we hit play. File doesn't exist. Directory not found exception. A path of whatever. So I forgot to add the little thingy before resources. So we're gonna go to our database and we'll add the little thingy before resources. I don't know who was trying to save though. Were you trying to save? Save data pad. If amount is positive. How would amount be positive? We go to our... Oh, I'm trying to save with this, which makes sense, right? Every game hour, I'm saving it, even if there's no feeding going on. Yeah, I didn't need the UI. I forgot about that little point. Okay, so file doesn't exist. And we will see that the thing should be created now. Yeah, we see the pet. We have food, happiness, and energy. So I'm wondering, why do we only have those? Oh, so the other thing probably are null, I guess. Pet. I'm gonna refresh this. Yeah, food, happiness, energy, 50, 50, 50. When we hit play, we will get the data for the food, so that means that our pet is getting loaded correctly. I'm gonna try and save, like increase this so that this gets saved. We can see that, refresh, it's saved correctly. I'm gonna hit pause because I feel like this is not, it doesn't seem like it's saving the date times. So I'm gonna check why that is going on. Okay, so it's not saving the date times because it's not getting initialized, I suppose. So whenever I load the data, we go do the callback here, and I do wonder why the save is not saving the pet, the part with the, it's probably because it's, again, it's probably because it's null. It's not initialized maybe, so I'm gonna go to my pet. I'm gonna go to my pet through the database manager. When is the pet getting created? Needs controller, so they timed that now, but it's because no one is initializing the pet yet. So I'm just gonna do a wake initialize, and I will say 100, 100, 100, 10, 10, 10. There we go. So that should work. Okay, we are gonna delete this guy over here because I'm not satisfied with the fact that it's not correct. Okay, we hit play. We are gonna refresh, there we go. Still not saving the date time. But why? food, happiness, and energy are getting saved correctly. Okay, so in here, whenever I save the data, well, not here. I'm gonna go to my save data T. I'm gonna go to my database manager, and I'm gonna say debug.log pet dot last time fed. See what it says. Okay. Oh, did I not make it public? Oh, I did make it public. Okay, so I don't know. I'm gonna delete this. This is just normal bug debugging and stuff. File doesn't exist. Yeah, we do have the times. And then if I click this, this actually should change. Yeah, it did change correctly. So there's something weird going on with that. My save is not saving the full amount of data over here. Database that saved data pet string JSON to save. Maybe if I read, I'm gonna try to read this. I'm gonna do debug.log JSON to save to string to see what it says. JSON material to JSON. So yeah, I can see clearly, like we can read this JSON and we can see that it's definitely not saving the date time that I wanted to save. So I play again so that we can read the result of that. Yeah, you can see here that it's definitely not saving it. So JSON to save data. See what else we can get here. Preprint from JSON, string JSON type. It's only saving a part of the thing. Pet save data. Or you just check out what the hell's going on. That's very strange because I'm very used to using JSON with Unity, and it's just not responding the way I expected to. So apparently I could add the serializable add thing here to make sure that it works. I just try that again. I'm gonna go to my project, delete this guy so that I'm sure that I get the new type of file. We refresh, well, we wait a little bit, now we refresh. We still don't get the full amount of data from it. Date time, last time fed, last time happy. What am I doing wrong? Okay, so actually I have done this with virtual pets before, so like this is not a test. This is actually something that I did before. Oh my god. So okay, so this is debugging. We have to debug why it's not saving the date times. So public int public date time using system is database using system just in case. That's why maybe it's just not understanding what a date time is. So I'm gonna hit play and see what is going on there. File doesn't exist. Yeah, I know. Refresh. Nope, that's not it. It's like cutting out a bunch of the data. What is preprint? Well, that's not it. I've never used preprint. From JSON, public static t from JSON string JSON type. I want to see. I'm gonna just try something here. So I'm just gonna make it a pet save data. Do I care about the type here? No. Why is it yellow? Why is this yellow? Oh, it doesn't know. It's not really my pet. That's better. Okay, so let's see what's going on here. I changed it from a generic to be a pet to see if that will help. Oh, delete that. So it generates a new object. No, that did not help. So the type is not the problem. String JSON to save JSON utility to JSON save data. Save data debug.log save data that to string. Let's see if I can do this. So I want to make sure that my save data is correct, right? So we're gonna go here and see what's going on. Pet string.pet save pet debug.log object database save data. It's like not taking in the full path, the full amount of data from my data. So save pet equals save data. Can't do that. Nope, cannot cast. So I'm gonna close Unity and reopen it to see if that helps. That sometimes does help. Close Unity. Then I'll click on my Unity hub again. And I don't want this right now, so I'm gonna go to my virtual pet tutorials. Oh my goodness, well this is why this session is called time passing and fixes, because this is insane. Okay, so the other thing that I could, and that makes no sense. Click play. Okay, so apparently the issue is that this thing is not designed for, what did I just change? I'm gonna delete this. Oh no, this is fine. That I'm gonna delete this. Okay, so the problem is that the date time is not something that gets saved. By JSON, which is very strange because I do remember having used it before. So we have to create a new struct. I'm gonna go ahead in the pet. I'm gonna create a new struct, and I'm gonna call it JSON date time. So this guy is going to be basically a fake creator of JSON date time, so that we can save it. So the thing that we are going to save is JSON date times. So we will go ahead and say that these guys are JSON date times. JSON date time, JSON date time. And why you're complaining, instant inconsistent public. We have to make this a public struct. There we go. And this is a JSON date time. So that way we should be able to save it. Of course, the database manager. Oh yeah, there's no problem. Apparently, there's no problem. There's nothing else to change. Let's see if that works. I'll explain how the JSON datetime works. I found it on Stack Overflow, as always. It's the best solution ever. So we hit play. We want this is saved. I want to save, refresh. Still not saving. It's still not saving, man. Well, why? JSON utility to JSON. JSON. We have serializable. We have JSON datetime. I might have to check my old scripts for this, which is very strange. I never have to change my old check my old scripts. I'm gonna go ahead and check them. So I'm gonna go into my files, and I will just show you some secret stuff that you should not be able to see ever in the life, but I will have to show you, because this is what I did for planning this thing. So I'm gonna go to assets. I'm gonna go to my scripts. I'm gonna go to abstracts, database maybe. Oh, okay. Remember, I never used JSON here. I used a database. That is basically what happens. Of course, data service. I used SQLite in my other project, which was compatible with date time, which JSON is not. That is very, very interesting. Okay, so that's very disappointing. And I can't implement a full database in Unity in 10 minutes, but maybe I can just figure out how to do this with the JSON datetime guy. So we have the JSON datetime, and we'll go to needs controller and make sure that this is a JSON datetime. Pet.json datetime, and maybe that will work. Hit play. This is a mess. I hadn't expected this. Okay, so we will delete this guy. Oops, I hit enter by mistake. Refresh and delete. Refresh. It is still saving without the datetime. Okay, so we will check what else is going on. Rays are not supported, I do know that. Saving system that datetime, no. Serialize datetime JSON utility. Unity. I'm gonna show you my search over here. So we have the things JSON, datetime, and set. Oh, maybe I can just save it as a string and then convert it to datetime, right? Yep, so I'm gonna do string last time fed, and all these guys are gonna be strings now. String, string. And I can just save them as strings and then deconvert them from string, right? Let's try that. I'm gonna go to database manager. You can see that this will be, oh, what? That to string. Did I change it in this controller? No, I didn't. So this is date time. And we will see that this is fine, but then we'll go to the database manager, it will be complaining. So pet equals new pet to string. So yeah, I can just try to analyze it from the string maybe. So let's try that, to string, to string. If not, we will just correct this in the next session, which is fine. We have about 8 minutes. Okay, so we have this. Now I do want to see if it gets saved. There will be a problem though. When I load the pet, return values pet, whatever. Okay, so delete this, hit play. Fresh. Now we do have the date time. So can we convert? Can we? I think we can actually. Okay, so what I want with my database manager, whenever we load, is give the pet the actual needs controller. I want to give it the data, right? So if pet's not null, instead of doing this, what I want to do is my needs controller dot initialize with the data from that pet. So we will do this, and we'll say food will be pet.food, happiness pet.happiness, energy pet.energy. Then we have input whatever the tick rate, so food tick rate. Oh, we don't have that. Well, whatever. Then the tick rate's gonna be 10, 10, 10. And that's a problem. So I forgot about that one. So I'm not initializing with this, but I do have to. If I'm gonna load from script, I have to initialize with that. So I'm gonna do a second initialize script, so that if we want, we can initialize with the date times. So we're gonna do increase this to be date time, last time fed, date time, last time happy, and then finally date time, last time gained energy. And then we will of course do exactly the same thing, except it's gonna be this that last time fed, this that last time happy, and then this that last time gained energy, and we will delete this to be last time fed. We will delete this to be last time happy, and we will delete this to be last time gain energy. Then we're gonna go to a database manager, and whenever we load this bad boy, it's gonna be a pet dot last time fed, pet dot last time happy, and then pet dot last time gain energy. And it seems that it's not complaining about it being a string, but it is. So datetime parse. We need system here, using system. Yeah, we're gonna need another. We're gonna need to finish this in another parse. Oh, what did I do? Okay, so it is parse. We just add datetime.parse so that it checks the time from the string, and we are good to go with the time passing by giving it the right time moment where the pet was fed. We go ahead and wait a little bit. We will hit play here. Now we're gonna right click, we're gonna hit here, we have all our stuff, and then the pet will definitely not show when it was last fed, but it is loading correctly. So what is the point of this? What is the point of that second initialization? So the point is to subtract from this, to change from this. We will do it. I'm gonna write it down. I'm gonna actually do it as a to-do. Finish time passing. So that to-do is gonna be done in probably in session 3, wrapping up and fixes or something similar, or maybe in 4.3. But the whole point is to subtract this time from the current time and know what the difference is with these energies depending on the hourly timer. So it's like whenever you get out of the application and then get back in, that is what it's done basically. So yeah, thank you for watching, guys. We've been working a lot on the date time thing. What I did to solve the issue, just FYI, is that I made the pet part, the pet manager, or rather the pet object, which I cannot find. The pet object's date times are strings. So whenever we save the date times, we save them as strings, and whenever we load them, we interpret them from those strings. We actually could probably do, I'm gonna do one last thing. I'm gonna do a debug.log, and I'm gonna log this. I'm gonna log that day, that date. I'm gonna log that. I'm gonna log whatever the last time fed is for this thing. We know that it's just now, like a few minutes ago from my time. So there's no mystery there. We hit play. Whenever we hit play, we'll see that this is not that far. So we have the date, but the hour is a little off, which is strange. The hour is a little off there. So maybe parse exact was better. Parse exact. Actually, not here. Exact. So yeah, that's basically what we did. We just figured out how to save. Oops. What does it take? String. Okay, that's not. Yeah, we do have the right time here. Oh, because I did the date. So that's basically what we did. We have our system where the pet gets saved, the pet gets loaded. You can see that the hour is correct, 18. So what happened was I was doing date, so it wasn't really showing me the hour or the minute of the saving. So yeah, thank you guys for watching. I'll be back very soon with the session 3 intro, UI, and minigame wrapper. And keep in touch. See you later. Alright everyone, welcome back to how to create a virtual pet game in Unity. So this is session 3.1, UI creation and hooking up. So we're going to be creating a very simple UI and we're going to be hooking it up to different functionalities along the game. So the first thing that I want to create, we already have a canvas, which is good, but I want a few buttons. I'm going to design each button in a same way. They're going to be standardized, but we will change the graphics. So we have a big button over here. This is a base button, and I'm going to create a few more. So I'm going to create another one. I'm going to move it here. I'm going to create another more one. I'm going to move it over here. And I'm going to create a last one. I'm going to move it over here. So I'm not actually sure what these buttons will do, but I do want a button for feeding. So feed button, and this button will button, and finally we'll have the minigame minigame button. So the other thing that we need in our UI is we need a few indicators for the stuff, for the different hunger and all that kind of stuff. So I will create a few images for that. I'm gonna having an image. I'm gonna create this image, put it over here. You right click UI image, and that's how you create an image, of course. And we need 3 images basically. We need an image for, well, I have to create an empty object actually. I'm gonna create an empty object. This is gonna be my pet UI. So all of this stuff is a pet UI. So why do we need two of these? Because the other one is gonna be my minigame UI that will be developed in the next session. So we're gonna be creating minigame UI. So we have this image. This is our food image. This is our this is not the food image. This is the happiness image. And we also have a third image, which is the energy image. Okay, now that we have the 3 images, I also want an icon for each of them. So I'm gonna create, copy this, I'm gonna create food icon. I'm gonna I wanna copy each of them because first they have the names already, and second they have the positions already. So we just have to move them a little bit and it will be fine. So we will have food icon be on the left of this guy. Then the happiness icon will also be just on the left of this guy. And finally the energy icon is going to be on the left. To create, just in case you don't know this, to get these arrows to move things, you just hit W on your keyboard. If you want to change for the other thing, this is the rect transform tool, which will allow you to like align things like this. You get these lines like in Photoshop. You just hit T. So okay, we have the food image, the happiness image, and the icons. So I'm gonna change the icon. I'm gonna click on this little circle over here, and I'm gonna get this food icon. And then for happiness, I need a smiley face. There you go, easy. And then for energy, I'll need like a lightning bolt. That wasn't that easy. So I'm gonna just check manually if we have a lightning bolt. There we go, energy. Actually, it's called energy. So I'm gonna recolor my energy thing to be yellow, and I will add an outline because I love outlines. If you have watched my other tutorials, you will know that I really enjoy adding outlines. So I'm gonna darken it, and I'm gonna make it a little larger on the x-axis, and then I'm gonna copy this component and I'll paste it on the happiness icon. Paste component as new, because I want my happiness to also have an outline. But as you see, well, also this guy, I guess. So paste component is new. We now have our stuff. So what happens with these guys? What happens with these images? So I'm gonna drag this image like this. So I'm also gonna I'm gonna check the size of this. So it's gonna be size 350 wide. So I'm gonna do the same for these other two. I'm gonna 350 wide. And as you can see, I can just drag them to the right so that I position them more or less correctly. So of course not gonna be perfect, doesn't matter too much. The whole point is that they are there. And food, of course, I'm gonna color it red. And I'm gonna change the graphic to be a little more, see if I can find something that's cuter. It has a frame, so it's called frame white. So I'm just gonna go ahead and find the same frame white. And the happiness, I'm gonna color it blue. And the energy, I am absolutely gonna color yellow, and I'm gonna change the graphic to the frame white graphic. I'm writing down here the name with my left hand, that's why you see it changing by itself basically. This is the minigame UI. Should not be an image, it has to be an empty thing. And now we have the buttons. So this is my feed button. I need some sort of, you know, food, or let me see if I can find something. Eat, no, I want to find something that is more or less alike feeding on this icon pack that I got. So it would be something like, I guess the food icon could be repeated, right? I don't want to repeat it though, but I will. I mean, it doesn't matter all that much. Okay, so whenever you add an image to any image, you should do set native size. And then you just hit the surf aspect and you lower the size manually, and it will not change the aspect ratio. It will always look fine. So this is my button. As you can see, it's not very button-like, so I'm going to try to paste the outline, and I'm going to make the outline like really obvious so that it looks like a button. So I'm going to copy component. Also, each button has this text element that I don't want. So I'm going to delete all these text elements from this guys. I will add the minigame, that means the outline to all of them. And we'll change the sleep button. Of course, it's gonna be sleep, some sort of icon for sleeping. ZZZ is fine. Set native size, as I said before. And we'll preserve aspect, and we'll move it to be a little larger. Just a little larger. Okay, so that is it for those two. And this is gonna be the game button. Oh, this is the settings button. So let's go and find a settings gear. Set native size, preserve aspect, and we make it a little larger so it looks a little better. Now we do the same thing with this guy, but this is going to be some sort of controller. There you go. So I typed in CONT for controller. Double click on this guy, set native size, preserve aspect, and make it a little larger so it looks all good. And let's check out how our UI looks. So there you go. I actually want to move these guys down, but first I'm gonna show you why you shouldn't do things in the order that I just did them. So what did I do? I created all my UI without taking into account the fact that the players would have differently sized screens. So what we have to do now is we have to go to our canvas, and we have to add we have to check the canvas scalar component. It's already here. So it says constant pixel size. That is wrong. We have to go to scale with screen size, and we choose a screen size that we want. So it's going to be 1920 by 1080 is going to be my reference, and you can change it to be adjusted depending on the height or the width. I'm going to make it right in the middle, and you can see that it didn't change. It didn't change much. That's because I am tricking Unity, because I have in my game, you can set up any sort of size for your game aspect when you test it. And what I'm doing is I created a new one by hitting here. I created one with the label 1080p, like so, and then I chose the width 1920 by 1080 fixed resolution, and that way we're sure that our test game over here is going to be in HD, basic HD. It's not like 4K or anything, but it works the way that it should work. So I'm going to select all these elements because we know that they are, oh, what happened here? No. I only want to select the buttons, and we know that they're like two on top of our creature, so we move them to the bottom. And even these things on the top, we can move them a little further up, just selecting all of them and moving them like this, just a little bit more. And now we can see that they look just fine. When we hit play, we can click on the buttons and they will act like buttons. These guys will not, because they're not buttons. So what's the plan here? We are going to set each of these to feed the pet. So I'm gonna go ahead and do the same thing. You can see it says change food. Well, I'm gonna change energy to 10 plus 10. This will not have that. Pop up the minigame UI. So I'm gonna do this, and then minigame UI, and I'm gonna do set active, or game object set active is true for the minigame UI. Whenever I click on this, it's gonna pop up the minigame UI, and then the other thing that's gonna happen whenever I click this button is the pet UI is gonna go bye-bye. It's gonna be set active false. So I'm gonna click on that and see how it happens. Well, as you can see, the minigame UI is active, so I'm gonna hit no here, so it's not active anymore. Hit play again, and then we click, and all of this will disappear, but the minigame UI is now active in the scene. So whenever we have that, we will be able to transition to the minigame user interface. Okay, so what's the next thing? We already have functions to communicate with our pet through our user interface. We will test that that actually works. I'm gonna go to my pet, I'm gonna hit save on my control plus S, because you always must have your stuff saved. And now I will check out this. I'm gonna hit play, I'm gonna check out these values. Anytime I hit this, so we can click on sleep and you will see that it's gonna increase. No problem, there's no problem there. They are working just fine. We of course don't have a happiness, because happiness is gonna be done through the minigame. So for now, this is not a thing. I'm gonna go ahead and delete this debug.log, because we now know that this works fine. And then the other thing that's gonna happen is whenever we, we need a pet UI controller to start with, because we do need that. So I'm gonna wait a little bit, and then I'm gonna go to assets, scripts, controllers, UI. I'm gonna create a pet UI controller. And for good measure, I'm gonna be creating a minigame UI controller, since I'm already creating scripts, right? So it's not a bad idea to have all your scripts created at the start, so that you can reference them and cross-reference them, even if they don't have functionality here. So minigame UI controller, we're gonna wait just a little bit. Minigame UI, I'm gonna add this, and then for the pet UI, I'm gonna add that. So we have the pet UI controller. Why do I need in my pet UI controller? So to start with, I need to add using Unity Engine .ui, and then I need a public image, which is my food image. I need my happiness image, and I need my energy image, of course. So now that we have those, we'll create public void, several public voids. So it's gonna be public void change, or rather update images. That's it. And then this is gonna take in an int food, int happiness, and int energy. So we're gonna go ahead and check our images, so I can teach you a little something, a little trick, a little Unity feature. So we have the food image, happiness image, and food image, happiness image, and energy image. So we're gonna go to food image here. Well, we're gonna select all of them. So we click on this, then hit shift and click again, so that we can be sure that they all get selected. And now you see that this has an image type thing. So it can be simple, filled, tiled, or sliced. We want it to be filled. And the way that we want it to be filled in this case is horizontal from the right, like this. So we just do it left, even though it sounds a little confusing. We do left, and you can see that the less this value, as it changes, it goes down. And it's from 0 to 1, which works perfectly, because it's just a percentage divided by 100. So in this situation, what we will do is we're going to go into a script, and we're going to update each image depending on how much food, happiness, and energy there is in our pet. And we can't do this the way we do in the database. We have to do this actually the right update. So we will go ahead and say food image, now fill amount equals food divided by 100. Then we have happiness image equals happiness divided by 100. And finally we have energy. I don't know what happened there. I don't know why I was complaining. I have no idea. Oh yeah, of course. That fill amount. So energy image, that fill amount equals energy divided by 100. And now we have our update image function in our pet UI controller. And I'm gonna do a static, I'm gonna make this a static void so that it can be accessed from anywhere. And these are gonna be static too, so that they can be adjusted with that. And now we have our little UI controller script. Now we're gonna go to our needs controller. I'm gonna do a little thing here whenever I initialize my pet, of course. Oh yeah, also I'm an idiot. I hadn't thought about this, so I'm just gonna do change, rather pet UI controller, change update images, and I'm gonna of course pass in my food, happiness, and energy. Oh no, this is fine. Yeah, this is fine. So I'm just gonna do this, and I'm gonna do the same thing here. There we go. Alright, so now that we have this, I'm gonna delete this. There's an extra line here, and now every time the pet gets initialized, they will update the images, which is correct, all good. But the other thing that we want to do is if the game timing manager, that game hour timer is less than 0, and we do this, we will update the images, or rather pet UI, rather update images, and we're gonna pass in our food, happiness, and our energy. But we're gonna do that after we update them here, so we're sure that you know, we're passing in the right value. So I'm just gonna wait a little, and I'm gonna go delete my save. I'm gonna delete my current save. Not here. I'm gonna go to my saves. I'm gonna delete this save because it has 0, -70 happiness, which is a little weird. So I'm just gonna go ahead and click play here. And if there's a problem, what is the problem? Null reference exception. Pet UI. Let's see. Pet UI controller. I had thought, I was sure that I had added my stuff in here, but apparently I did not. So let's see. Oh, it's because they're static, so we cannot make it. Oh, that's very sad though. We cannot make it happen this way. So we have to adjust this a little bit. So I'm gonna do a private int food, happiness, energy, and we will just say this dot food equals food, not that one, comma. So this dot, oh, I can't do that either because they're not static. Public static. This is not valid, of course it's not. So I'm just gonna do current food, and I'm gonna repeat that little beautiful word current in all of these guys. Public, not public, I'm gonna do private. So I'm gonna do current food. I can't do anything. This is the only limitation of these guys. Okay, so I'm just gonna have to delete this, and I'm gonna have, of course, to do the beautiful instance thing with the pet UI manager, pet UI controller. So I'm just gonna do a public pet UI controller instance, and in a way, as always, instance equals this, and we'll do pet UI controller. And we delete this. Oh, no. We just remove the static word so that it can update correctly. Okay. Yep, that works perfectly. It looks fine. And of course, you'll see that Unity is gonna complain about something because Unity loves complaining. So this is gonna be instance pet UI controller dot instance dot the images. And apparently pet UI controller, I forgot to set a static pet UI controller. So this guy should be fine now, and now we need the instance here, and we have this amazing update UI images. We're gonna wait a little bit, and this is instance also. We'll wait just 1 second, and we reassign. It's gonna appear here. We'll reassign the images again. So we have the food image. There you go. Like, you're learning so much. Like, whenever I mess something up, You guys learned like 3 times what I thought you would learn. I'm a great tutorial maker. You have to give me that. Okay, so we now have this in, and now we'll hit play and see what happens. So okay, we'll wait. Whoops. Okay, so that was extremely weird. But I do think I know what's happening. So what's going on there is that our pet UI controller is dividing this by 100, and the result is an int. So the fill amount is a float, and the result of this is an int. So it's either 1 or 0. It's never gonna hit me with a float. So we have to convert that value to a float so that the value actually spits out a percentage, which is what we're looking for. We're looking for a number that is, divided, divisible, basically. So we hit play. We try this again. You can see that it changed. It's going to be lowering steadily. And if we go to our pad, we can change the tick rate to be 5, 15, and 7. And it will change the different rates for each of the objects instead of going at the same pace. And we can do that again in a second here. I'm going to go to my assets. I'm going to go to my saves. I want to go to my saves because I want to, of course, reset the numeration, the numeric values. I'm going to go to my pad, and I'm going to change the values. I'm going to say 5, 1, and 2. And I'm going to apply this. When I hit play again, and you will see that the food is going to go down real fast while happiness, oh, that was interesting. Why did it get set to 10, 10, 10? Come on. So I initialized it wrong here on awake, basically. So I'm going to have to do it here, 5, 2, and 1. I'm going to go ahead and reload that. Hit play again. And wait. So now that they are changing, you will see that the food is going to go down way faster than the other values, except it already still says 10, 10, 10 because I probably have it on save. Let's go and check my saves. I don't know why it's setting it to be 10, 10, 10. Am I loading 10, 10, 10? Come on, don't tell me I'm loading 10, 10, 10. I'm not. So I do wonder why it's changing to 10, 10, 10 when I don't want it to be 10, 10, 10. Yeah, it's not changing anymore to 10, 10, 10, which is good. As you can see, the numbers here 90, 96, 98, and of course the numbers, for example, the energy is going down really slowly. It's still there, right at the top, while the food is going way faster. Gonna go away very much faster. So that is our UI creation and hooking up. I believe we now have well, I'm gonna just do the preface thing. I'm gonna do a small recap now about explaining what happened during this tutorial. If you guys have any questions, please ask me. You can ask me on the website. You can email me. I'm very active. I love responding to questions and helping everyone that may need my help. So continuing with this, I will say that what we did was we created a very simple UI, and this UI has a few icons, one for food, one for, I'm going to change the color of this, one for energy, or rather happiness, and then one for energy. And we also have these pretty little bars here, and these bars, what they indicate is how much of that resource is left, because basically these are just resources. That's exactly what they are. And by analyzing these resources, the player can assess what they will do. Remember, your UI must have an impact on the player. And we also created these 4 buttons. One of them is the settings button that will actually create the settings UI that will probably not get used. Empty, and in an empty game object is going to be a settings UI, and we hooked up all these buttons to feed or sleep. Well, right now sleep, all it does is just restore energy, and we can also open the minigame UI that doesn't exist yet, but the point is that it will be added at a later tutorial. Maybe the settings UI will also be added at a later tutorial. And so that is all that we did. We created a UI and we completely configured it to work with our our current game state. So we have a pet whose needs are lowered. We have a UI that shows the needs, and we can also restore part of those needs, and we also can navigate our user interface. We can get the game to go into different states. So yeah, that's it for now, guys. Thank you for watching. I will go ahead and stop this video, and we will come back later with session 3.2, which is minigame UI interface. Thank you for watching. I hope you guys come back for the next one. Alright everyone, welcome back to how to create a virtual pet game in Unity. This is session 3.2, minigame UI interface. This session is gonna be actually really short because the UI interface is not something too spectacular. It's not gonna include any coding or anything, I think, at least. So the first thing that you must do whenever you're gonna create a new UI interface is delete, or rather deactivate, your previous one, and then you activate the new one. And what is my pet, my minigame UI interface going to have? So every single UI interface has a few things. The first thing that it has is a score value, so score text, and usually this text for the score depends on the type of game, so we just have to leave it open to whatever type of game it is. I'm just gonna make the text larger, I'm gonna make it black, and I'm gonna increase the horizontal size so the many things can fit in here. You can also have an image, which can be your score icon. So depending on the game, you can let your, you yourself allow yourself to create different sort of sprite depending on the game. So you see like books, maybe bombs, maybe you have hearts, maybe you have whatever you need. So I'm just gonna place heart because a heart is pretty. So I'm gonna add, of course, you know what I'm gonna add. I'm gonna add one of these beautiful outlines. Unity already knows me very well that I love my outlines. So we have our text for our score. I'm gonna make it centered on the left side, that's fine. The other thing that you must add definitely on any minigame UI is buttons for the settings, or like pause buttons. So I'm just gonna add a new button, and this is gonna be my pause button that will allow me to pause my game. So I'm just gonna find the pause icon, and I will set native size. I will add an outline too. I'm gonna make it a little larger so it's very visible. We're not place it on the top left, rather on the bottom right, I think it's better. Actually, I'm gonna make it a little larger, so I'm gonna preserve aspect. I'm gonna make it quite large. This is a game that could be compatible with, definitely could be compatible with mobile settings. So the other thing that you probably want to have in your minigame UI is some sort of time stuff. So instead, I'm gonna copy these two guys, and I'm gonna move them to the left, to the opposite side, and I'm gonna call this one time text. Nope, time text. And then we're gonna create another, change the name of this to be time icon. And my time text is gonna remain the same, with my time icon is of course gonna change to stopwatch. I'm gonna change the color to green, why not? And I'm gonna of course set native size so that it adjusts itself to the correct size horizontally and vertically that we want it to have. And that's basically it. So that's our minigame UI interface. If we're gonna make it mobile, of course we must add buttons for two buttons probably for our controls. So if you have a mobile game, you want something like A and B, or left, right, up, or something like that. But in this case, we don't really want to have that kind of stuff. And that's our minigame UI. The one thing that I could add, that I want to add, is another thing. I'm gonna create a new panel, and this is gonna be my minigame and panel. And the minigame and panel is gonna have I'm gonna copy this text and this icon, and I'm gonna make them be inside here. So it's gonna be like title, minigame and result text. and this is gonna be the minigame and icon. And for the minigame and icon, I will select something like massive coin. Why not? I'm gonna make it quite larger. I'm gonna set the preserved aspect. Don't forget that. Set native size. And now I'm gonna just make it quite larger. And I'm gonna make it yellow. And then the result text is gonna be here, and it's gonna say you earn X amount of coins. And I'm gonna make it a little larger, a little more vertically aligned. Not coins, probably happiness, because we don't have coins. Like that. I'm gonna actually center this guy. I have to reduce the size. And I need another text, and this text is gonna be just a title text. So it's gonna be minigame end title text. And we're gonna say minigame has ended. We're gonna center this text. We can see that this text is not in the center. I'm gonna place it like right in the middle, like the song, and then we're gonna center this guy according to that other guy. And now that we have this set up, I need another button. I need a button that's gonna be the go home button. So it's gonna be home button. I'm gonna add it here, and I'm gonna change the icon to home. And I will change the color of that icon to be red. And the functionality of that icon is going to be deactivating the minigame UI. Set active is false, and then we're gonna add another one, and it's gonna be the pet UI being activated. So game object set active is true. Now for the pause button, I'm gonna do exactly the same functionality actually. So I'm just gonna, can I copy this? No, I can't. So the pause button is not gonna activate any sort of settings UI. I'm just gonna go back to the pet UI. So pet UI and minigame UI, not that, minigame UI. So it's gonna be just game object set inactive, and then game object set active. This is gonna switch between the two views. So whenever we switch from the one view to the other, something's going to happen. That's going to be in session 3.3, which is the wrapping up session, which is going to be wrapping, creating the wrapper. That's like a little pun that I added there. So what is the other thing that we need? So we need to create functions for the minigame UI controller to update the user interface. So we're gonna wait a little bit until Unity loads this, because I had closed it by mistake. So we're gonna add using Unity Engine .ui, and you can guess that we will definitely do the instance thing. So I'm just gonna copy this and add it to my minigame UI controller and do a public static minigame UI controller instance. And this is gonna be minigame UI controller, and we're gonna have, of course, a few elements here. So we're gonna have a public text, score text, timer text. We have the score text, the timer text, and that's basically it. And we're gonna say public void update score and score. And we will go ahead and say score text, that text, like this, equals score space plus score. This is one way to update it, and now I'm going to show you the other way. I'm going to do public void timer text, or rather update timer and timer, or rather float timer. Timer text equals text equals string.format time left, and then we do 0. That way we are physically aware of where the time is going to be. Timer. So this guy is going to substitute the 0, and you can do 0, 1, 2, 3, whatever amount of objects you want to input in your text. Okay, so now we have those functions. We have a way for the minigame UI controller to get updated. And the other thing is a public void finish minigame. And we will add a, no, that's fine. I guess for now we're gonna have all minigames have the same result. Okay, so now we have all the minigames have the same result. We need to create a public game object, minigame, and screen. I will not call it screen, actually, I should call it UI. And for finishing the minigame, we would just say minigame and UI dot set active is true. And that is basically what we do with our minigame user interface. We just set up a little score updating method, a little timer updating method, and a little finish minigame method here. So that way we can interact with the user interface from other scripts. So yeah, that's it for this session. It's a very short session. I will be correcting the error with the time passing in the next session, and also I'll just be adding the last part of the functionality of this thing in the next session. So it's gonna be a little longer, or rather quite longer. Also, this has to be off. This is the standard point with this thing, so I'm gonna hit play here, and we'll be able to actually see the minigame screen, and if we hit pause, it will come back to the other screen. Of course, this is not the right functionality. This is gonna teleport, this is gonna like instantiate stuff or change stuff for the minigame, but that's not defined yet. We'll define it in 4.1. So that's it for this session, guys. Thank you for watching. I hope you guys are excited to continue. In session 3.3, we will wrap up the minigame interface. We'll allow communication with the minigame interface, and then we will, well, not allow communication. I would say create a base minigame controller, probably, yeah, something like that, that communicates with the minigame interface in a basic way, and then we change it when we create the actual current final minigame, which is going to be session 4. So yeah, guys, I will see you later, and I hope you are having tons of fun and learning tons of things. If you guys have any questions, please ask me through the website, with email, or anything that you may need. So goodbye. Alright everyone, welcome back to how to create a virtual pet game in Unity. So this session is session 3.3. It is called wrapping up and fixes. So what we're going to be doing is we're going to be creating a base minigame controller, and this base minigame is going to allow communication with these, well, not with these, but with the score and the time in our, let me just find it, in our minigame UI. Let me deactivate this and activate this. So our wrapper has to be consistent of a minigame, of course, a base minigame controller, and our minigame UI controller must be one of those globals that we are being using, one of those instances, so that anyone can communicate with it without needing to know where it is, basically. So the first thing that we need to do, as you can see here, I never assigned the texts for this kind of stuff, so I'm just gonna go score text here, and then I'll get the time text and assign it here. And then finally we have the minigame and UI, and that is this guy. And that's basically what we have to do with the minigame controller for now. But the other thing that we must do is we have to check that this guy is an instance. And he might be, so let's check it out. Yeah, as you can see, this already is an instance, so there's not going to be that much of an issue to arrange that sort of stuff in our game. So I'm going to go back to the controller, and I'm going to create a new C# script, and I'm going to call it base minigame UI, base minigame controller. And our base minigame controller is going to be used as a parent class for each of the minigames that we create. So Basically what we need here is a few functions that our new class can implement. So what is the thing here? So there's two ways to do this. There's a way called an interface, and we can also do the public class thing. So what is the difference? An interface forces anyone who uses that interface to implement certain functions, but the interface itself doesn't have any functionality. So what you're basically doing is making sure that whoever implements this sort of thing, that you know what classes, what functions it has. But you're also wasting a little resource, which is you are not allowing yourself to get any real information for what's being done with this. So basically, what do I mean with this? Well, I'm gonna create, for example, I'm gonna create a protected override void, rather protected virtual void awake. So what is my protected virtual void awake going to do? What this means is any class that inherits from this guy has access to this class, and they can change the functionality from the awake function. So in the awake, we have to assign where the player is going to be. We have to assign many things that we might need for this, sort of thing, for this sort of base controller. But there's many things that you could do, and the main thing that you want to do is communicate with the UI. So actually, I'm not gonna do anything awake yet. I'm gonna create a protected virtual void, and I'm gonna call it increase score, and I'm gonna do int increase or int amount. And you can see that there's already a problem here. So what score are we increasing? We need a protected int score. In the case that our score is an int. Also, we need a public int timer, which is going to be the float timer, which is going to be the time that this minigame can take. So to increase the score, we will do score plus equals amount. I'm sorry, I'm yawning. I don't know why. When I get concentrated, this happens all the time. So score plus equals amount, and then we will add something else. We're gonna go and add minigame UI controller that instance dot update score, and we need to send that score to our UI. So I'm just gonna send the score, and the UI will update the score accordingly. Then the other thing that we must do is get a protected virtual void lower timer, or rather change timer. We're gonna do a float change, and we're gonna just do timer equals or rather timer plus change, and I'm gonna do the same thing to the score. Actually, I'm gonna call it change score, so that we can lower the score or increase it, and it in only one function. So then we go minigame UI controller that instance that updates timer, and we're gonna send in the timer that we now have. So if the player, for example, picks up a timer bonus item or something similar, they will update the timer through this change timer. And now we need a protected virtual void update. So we need the update function in our, we can F12, we cannot F12 that. So what we want to do with this is change the timer with the passing of, the delta time, as always. So we're gonna do change timer, and we're gonna change the timer by minus time dot delta time. And here we'll say if timer is lower than 0, then we will ask the minigame UI controller to enable the end of the game. We're gonna do finish minigame. So we're gonna do here minigame UI controller that instance that finish minigame, and I'm actually going to do something else with this finish minigame. I'm gonna pass in the score. So I'm gonna do end score and float time. time remaining. This is in case we have a minigame which has a certain amount of time remaining, so that the minigames like reach this point. You have to be aware that maybe there's a minigame that does that, so we will just make sure that this is compatible with that. So we're gonna go ahead and send our score and our timer here. But as you can see, I have this condition where if timer is lower than 0, this happens. So the other thing that we need to do is we need to destroy the minigame. So I'm just gonna send in I'm gonna create this function maybe. No, I'm just gonna do destroy game object. So what this is going to do is it's going to destroy the minigame game object if the timer reaches lower than 0. Of course, there's a lot of things that you could do with this. A lot of interactions. Maybe you want to wait a little bit. So I'm just gonna time it to be 1 second. So the minigame UI is gonna showcase my finished minigame, and then 1 second later, my object is gonna be destroyed. So you can see I can just do 1 here, and it will destroy the minigame, the game object after 1 second. So yeah, that's basically it. The next thing that I want to do is okay, now that we have the finished minigame, I also want to create a protected virtual void. Or rather goal reached or something, goal reached. And this will also finish the minigame, but it will finish it with some time left. So it's gonna be minigame UI controller, that instance, that finish minigame, and I'm gonna send in the score and the timer. And we will also destroy the object, game object, but we're gonna destroy it immediately because I don't want ever the timer to reach 0. If the timer reaches 0, then we'll have 2 objects who are going to be trying to, finish the minigame, and then the UI controller is going to be confused and our game is not going to work correctly. So whenever we reach the goal, we will destroy the game object and send this information to our friend, the minigame UI controller. So that is a wrapper. Basically, that's a wrapper. The other thing that we must be aware of is the way that the minigame will be created. But I will not talk about that now because that is part of 4.1 minigame definition. We're going to talk about how the minigame will be included. So yeah, but that's basically the way that a little basic wrapper is created. You have to think of the objects of the important interactions that you have, which is changing the score, changing the timer, lowering the timer, and then finishing the minigame. But there's one more thing, which is starting the minigame. So whenever you start the minigame, you might want to initialize this, maybe. Do we want to initialize? No, I don't think we need to initialize. But what we'll do is I'll make sure that my timer is never 0 at the start. So I'm gonna do if timer equals 0, then we'll increase it to be 30. Timer equals 30. So this way, or rather, I'm gonna do change timer, just to update the UI. I'm gonna update it by 30 so that it increases the second amount at the start to be at least 30 whenever we're starting the game up. So what that will do is if I forget, if anyone forgets, if any game designer who is in charge of updating that stuff forgets to set the time, then we will have a timer that will, not be 0, and it will not instantly finish the minigame. Oh, what's going on here? I didn't want to load a scene. Okay, so this is our minigame UI. We have our minigame wrapper. I'm gonna move on to something else that we must do because this session is called wrapping up and fixes. If I remember anything else about the minigame, base minigame controller, we will come back here. But for now, I think that is completely fine. So the next thing that I want to deal with is actually the fix of the timing thing. So I'm gonna go to my pet my database manager, I don't even remember who has the thing. I think the needs controller, yeah. So we need to finish the time passing. So what's happening here? We know when the pet was last fed, and we know the amount of food, but we also have to calculate the difference between the moment when that feeding happened to the current time. So let's say you fed the pet 3 hours ago, and the in-game hour is 6 minutes. So you would have how many feedings? About I think it's 30, because 6 minutes times 10 is 1 hour, and then 3 hours is 30 feedings. So we will have to reduce the current food by tick rate 30 times, and then show that result to the player. And actually we'll have to just change food a certain amount, right? A certain amount of tick rates. But the amount of tick rates is actually what we have to figure out. So how do we do this? There's a way to compare date times. We can add date times. I'm going to show you in a second. So we can add date times, and that way, I mean, not add, subtract, and that way we can check out what or how much time has passed since our last feeding of the pet, of course. So the way that we do that is by basically comparing our date time. So let me just check 1 second over here. I have this I have this thing where I already compared it once. But yeah, basically our timing has to be very smart. We have to be really aware of what time is the one that we care about, right? So we have to create a function or maybe a class that deals with this, but I don't think we need a full class. I think with a function here is fine. So we need an int. We need an int that is the amount of the difference that we need for this. So we have a public int. It's gonna be called tick amount since last fed, could be, but that's not right. I'm just gonna do tick amount since time to current time, or something similar to this. So this function is gonna take in two little points, only 2 points. So it's gonna be a date time. It's gonna call it since, or yeah, since is fine. And then we'll have the a float, which is gonna be the seconds. Oh yeah, so float seconds or something like that. So we will be checking out the amount of the difference between one date time and another. So I'm gonna just check here. So we must check each part of the date time separately. So basically we have the year, month, day, and hour and minute and second, right? So there's a problem with this. So we know that if the year is too different, then like if the year is different at all, the game is dead. Whoops. So the game is dead. So what we're gonna do is we're gonna first store our current date time. So date time current equals date time that now, and now we have our current time. So we're gonna say if current that year is more than last since that year, then we're going to return a big amount. So that just the pet is dead, of course. So we're gonna do just 1500 basically. So if the player hasn't played the game in a month, then that also happens, right? because it's a month. It's you haven't opened your app in a month and your pet is dead. So current that month, if it's more than since that month, or rather, I don't know if this would be since. I don't think. I'll just do last time. I think that's better. So if current that year, current date time, if current date time that year is more than the last time that year, then or month, then we will return 1500. So this means that that there's at least a 1 point difference. So if we're in month 2 and the last time was in month 1, then you will kill the pet. But there's also a problem with that, where if the month is if the month is, for example, if we just changed months, then this shouldn't happen. So we have to still compare that. So I'm just gonna check if current date time that day. So you can get the day of year. So I would probably rather compare the day of year instead of the month year. So I'm just gonna say day of year. I want to get the difference between the days of year. So I'm just gonna say int day of year difference equals current date time that day of year minus last time that day of year. So this will give me the difference. If this is day 300 and this is day 150, then it's gonna be a 150 day difference. So I'm gonna say day of year difference is more than let's say 2 weeks, so 15. So if the difference between these 2 points is a year, or so we have the same issue here. So what is the issue here? If the year just changed, what happens, right? So maybe we don't really want to do this, but I'm not gonna go too deep into this. Let's assume the players play in the same year, and if they change years, maybe we can deal with it in another way. But for now, we're just gonna kill it if the day of year is different. I mean, the year is different, or if the day of year difference is more than 15. Okay, so that is like my kill moments. So what is the other thing that we have to do? So current date time has a lot of data. So we have the add days, hours, milliseconds, add years, date, day, and we also have the hour. We have the kind. What's the kind? I don't know what that is. We have millisecond, minute, month, second, subtract, ticks, time of day. We have a lot of things. So we want to check how many years different, how many days difference has it been. So how many days is acceptable. So we already said that 15 is already too much, but I'm gonna say 1 week is already too much actually. So if there's more than 7 days difference, then we will not even check. What it means is if there's a week difference, not this way. If there's a week difference, then we already assume the pet is going to be dead. So we're gonna have to play with 6 days for this whole process. So what is the 6 days about? We will be saying that current date time. So we already have the year difference, the day difference. So the first thing that we need to do is we need to multiply the number of days to get the seconds, right? So how many seconds are there in a day? So we just go in Google and say how many seconds are there in a day, and we get the amount of seconds. There are 86,000. So we will say float seconds amount equals the day of year difference times the seconds, or rather times 86,500. So this is day difference, our day difference seconds amount. So if there's 1 day, it's going to be 86,000, but if it's not, if it's 0, then this will be 0, which is fine. So in case that's 0, we have to differentiate the hours. So if the player hasn't played in a number of hours, then we will check that out too. So we need an int, or rather a float, hour difference seconds amount. So what we will do is we'll get the current date time dot hour minus the last time that hour, and we'll multiply that by 3600, which is the amount of seconds that we have in a day. We're gonna do this parenthesis thing here, and now we do that, and this is the hours difference amount. This is, as you can see, this has a problem where if there's more than a day difference, then this is not worth anything. So we will say if day difference amount, or rather day of year difference is 0, well, it's not 0, then we return. Oh, we return day of difference seconds amount. And of course we can't return this, but why can't we? Well, basically because this is a float, so we have to do int that round, or rather mathf that round to int, and we'll round the seconds to be an integer, and we're sure that it will be fine, should be fine. Or I mean, we could just make this an int, right? Yeah, so we can just make that an int and return that. And if there's no days of difference, then we'll return the hours difference, only hours. That's fine. We'll assume that an hour has passed. Well, yeah, I mean, that's fine, right? Yeah, if an hour has passed, yeah, we're fine. So if hours difference amount is more than 0, then we return hour difference seconds amount, and again, this is an int, not a float. What else? So if there's not even an hour difference, or a day difference, or a year difference, then there's only minutes difference. So we'll go and say int minute difference seconds amount equals current date time that minute minus last time that minute. We multiply by 60 because that's the amount of seconds in a minute, and that is our minute difference seconds amount. And so we say if minutes difference seconds amount is more than 0, then we return that. And last but not least, if the player is checking even not a minute has passed, only a few seconds, then we need to check that too, right? So we're gonna go if, or rather int second difference amount. So you see why I didn't do in that old tutorial, in the older tutorial? Well, that is why. So we just do current date time that second minus last time that second. And now we have the second that happened. So we're gonna return second difference amount, and that's gonna be like our baseline. If everything else fails, we return this. So that is the tick, is actually not the tick amount return here, because we haven't judged. This is actually the tick rate. We haven't judged the real problem, which is comparing the amount of seconds, or the amount of the second difference basically with the tick rate. The tick rate is always going to be in seconds, so I'm just going to type that in seconds. And then we're returning forcibly here 1500, and returning here basically the days difference amount. But over here, we are already wrong. So we have to divide this by tick rate in seconds, and we have to say mathf the round to int that number. That is the only difference that we have to do. We have to round the result down when we divide it by tick rate in seconds, because we want to know how many ticks, how many times the global cooldown would have happened if we had stayed in game, right? So that's the only change that we need to add, which is the tick rate in seconds division. As soon as we divide this, we can be 100% sure, well, almost, that we're returning the right amount of seconds. Of course, this is hard to test because we can't. I'm not gonna wait 3 hours or a day here to test it. But this is the code that will lead you to the tick rate, the tick amount since time to current time. I'm gonna call this last time. Okay, so now we go back and I'm gonna teach you, learn this part really well. This is the key to saving and loading the Tamagotchi. Oh well, of course the JSON and stuff also is key, but this is one of the keys, basically. Okay, so we're gonna go back to our this guy to do finish time passing. So this is gonna update the images wrong because it doesn't have the judgment of tick rate. So the int that we get here is the number of ticks. So what we will do is say food, or rather this dot food. We have to change this formula. So this dot food equals food times tick rate, tick since whatever, tick amount since last time to current time. Last time is last time fed, and current the tick rate in seconds is our food tick rate. So that is actually our food amount. We have to multiply. Is that correct? Food tick rate? No, that's wrong. Food tick rate is the amount that is lowered by. The food tick rate is the amount lowered every time. So we have to. This is actually food equals minus food tick rate times. Okay, I get it. So it's food minus food tick rate multiplied by this is the global. Our timing manager has the global value, which is the game hour timer, or rather, yeah, I guess. Let me just go check that this is correct. Oh, we need the hour length actually. So hour length. Why can't I access the hour length? Oh, I get it. So because it's static. Should be fine. Okay, there you go. So we are checking the last time we fed, in this case, by the timing of each hour. So if the hour would be 100 seconds, it's different than 1,000 seconds, of course. We are multiplying that result, so the amount of times that we have fed, or the amount of ticks that happened between the last feeding to now, and we multiply by the tick rate, and then we are lowering the food that we're bringing to the pet by that amount. So we do the same thing for the other guy. So we have happiness minus happiness tick rate multiplied by tick amount since last current time, and we have the last time happy, and we have time manager, timing manager, that hour length. We are going to do the same thing for energy, so I'm just gonna copy this part of the code here. So this would be energy tick rate. As you can see, we can't really see the end of this function, so I'm just gonna bring it down here. It's no big deal. I don't like having functions that I cannot see. Actually, this is wrong. You have to do it from the minus. So here, there you go. That's better. Even that is not enough. There you go. So we're gonna do the same here so that this is visible, a little more friendly to our eyes. So we will do minus and then multiply by. This is last time energy, and then we have the hour length 2, and we have this mysterious friend over here that I don't know what it does. I don't think it does anything actually. And okay, this is the real energy thing, and this is the real calculation. And so now we will have update images, and I'm going to assume that if this works right, let me just, when we load the game, the pet UI is gonna show everything in 0, probably. Just see if I have a save, resources, saves. I do have a save. Last time fed was yesterday at 7 p.m. It's 10 a.m. So let's just check it out. Yeah, you can see that the tick rate worked. Did it though? Check the number of this. 25. No, it didn't. What's this? Timing difference calculator. Okay, so what happened there? Let's check it out. Happiness minus happiness tick rate. Tick amount since we have food 25, happiness 46 here. I do want to know the calculation result, of course. So I will say, let's see, current time, that minute, day year difference. I'm gonna debug.log this day difference amount, because we need to know what's happening here. It should say 1, right? Should say 1. It says 86. Yeah, of course it says 86,000. So now we're dividing by, this is wrong. This should be if it's more than 0. If it's more than 0, then it will change the result there. Okay, so now I'm gonna actually return this amount. I want to check what my tick rate, like this number is. So I'm just gonna do debug.log that number. We're gonna confirm that this number makes sense. We're gonna hit play. And the number is negative something, a whole bunch of numbers. What would that be? Round to int day difference seconds amount, which we know is this number because it's 1. And then we have round to int that number divided by the tick rate in seconds. The tick rate in seconds is the hour length, and our hour length, let's just debug.log the hour length, of course. So debug.log hour length, tick rate in seconds. And now we will go ahead and check that out. Oh, it's 0, of course, so Unity is freaking out about it. So the hour length is apparently 0. I'm just gonna go ahead and check out why would it be 0. Where's my timing manager? Oh, no one. Oh, of course. So that is the problem. So we have to do the little instance thing here too, just to be sure that everything works fine. I'm gonna go ahead and do a public static timing manager instance. In an awake, we're gonna set the instance to be, of course, the same thing as here. We're just gonna copy this code and we will do it with the timing manager. And we'll go ahead and do this and do timing manager. Okay, now that we have this, we will check out the, a second, I have to confirm that all my code still works, right? So as you can see, when you change some small stuff, oh, whoops. Oh yeah, this is gonna be instance, and everyone's gonna complain about this change, so we just have to update everything that complains to be using the instance thing. As you can see, here's the same. So instance, and then we go ahead and I think that's the only one, is it? Nope. Oh, that's corrected. There you go. So that will be instance here, and I will wait a little bit, and everything will be fine. We'll have our hour thingy here. So our hour length is what we want to do. I want to set it to 15, and this number is not going to be 0 anymore, so we will be fine. This calculation is going to actually make sense. So this is the amount of ticks that we are getting from this thing. So now, as you can see, it didn't really change. Well, maybe it did. Let me just check the save. Let's refresh. Okay, so it didn't really change the thing. Even though we do have the code is working, it didn't change the amount that we are saving, that we have in our pet UI. So we're gonna go to our pet. Where's my database? So we have the food minus food tick rate multiplied by that amount. So what happened with my food tick rate? This number. So this number is a mystery to me. We have to check out why it's not the right number. So debug.log that number. And now we click on play. I'm gonna remove what were you waiting? What's up? No, we need another parenthesis here. And we need to delete this probably. Yep. Okay, so we're gonna debug. This debug is deleted already. Good. Yeah, because we know it's working. That part is working at least. So we're gonna reload the game and check out how this works. So we see that the number is an insane number. Oh, okay, so that is the point of this. So of course this is gonna update with the food, happiness, and energy, and then it's gonna try to do the thing, but it's not gonna work. So I'm just gonna say, well, actually this is wrong. It's not updating with food. It has to update with this.food. Now that's a real error. This.energy. That's a part of the real error. So I have to judge if food is less than 0, then food equals 0. Then if energy or happiness is the second one, happiness is less than 0, then happiness is equals to 0. You can already probably predict that I'm making a mistake here. I'm not using the this thing again. So this, I'm gonna add the this denominator so that we know that it's not the value that we're passing in, it's the value that we have in the needs controller. So if this.energy is less than 0, then this.energy equals 0. Okay, now we have the real values in our thing. And now when I hit play, it will probably show zeros. There you go. It shows zeros because my pet, you know, it's not really healthy. It hasn't been taken care of in a long time. It didn't save because not enough time passed. But that is the whole point here. So we have, now I'm happy. Now we do have a system that is judging the saving. I'm just gonna do Control A, K, F, Control S, and we have a better looking code, some better looking code. So we have our, I'm just gonna separate this a little bit because it looks horrendous. Like that, that's better. Okay, so we have a code that saves a pet with the time that it was last fed, and then we can calculate how much food the pet is going to need after that amount of time passed. So if it has been, why is this over here? That makes no sense. It should be over there. There you go. Oh, I know why. Okay, so it will be reduced by the amount of time passed. So if there's only 1 hour, the game knows. If there's only 1 second, the game knows. If there's I'm just gonna have to do this again. If there's a million seconds, then the game knows. and the game is prepared. There's some alarm sounding near me, so I'm sorry about that. So yeah, if the game detects that days have passed, then the game will return the amount of seconds per day instead of calculating hours. And of course, this will be a problem for people who stop playing for like 1 hour at midnight or something. But we are not gonna go that precise. We are able to go that precise, but this is fine for a prototype. This is just like a proof of concept, proving that you can do this is fine. If you want to go deeper, which is possible, I'm gonna go ahead and tell you that what you have to do is check if the dates are, of course, if there's only 1 day difference, you can check the last hour of the first day and the current hour of this current day, and then you subtract. So if the hour is like 13, so it's 1 p.m. and then you stop playing at 11 p.m. the previous day, you know that there's a 14-hour difference, and you can multiply that in this way, like with the hour difference that I have here. That's why I calculated hours, minutes, days. The same thing for minutes. You can check, so if the player stopped playing at 11:45 and it's now 12:30 of the next day, 12:30 a.m. of the next day, there's only a 45-minute difference. You will not punish the player for that, so you just have to set it up here. So it's gonna be like a couple more logic leaps here, logic structure here. It's just gonna take you 10 more lines or something, but I am not delving that deep because again, it's a prototype. So that was session 3.3, which is wrapping up and fixes. We created our base minigame controller, which is our wrapper, and we have the UI already set up for both situations, for the minigame UI, the pet UI, and our buttons work, and we can communicate to the player what they want or what they need to do. So thank you for watching, guys. I will be back very soon with session 4 intro for basic minigame creation. We're gonna be creating the minigame to close up the tutorial series. So this is already without the minigame, you already have a working, fully working Tamagotchi with animations, with all these sort of buttons, with the UI, with all these things that will make it for a good game. So I'll see you guys soon. Alright everyone, welcome back to how to create a virtual pet game in Unity. So this is session 4 intro. We're going to be talking about what we have already and what we're going to be doing in session 4, which is our last session. Last few sessions, I guess. So what do we have? We have a fully functional pet. So this pet can already animate itself. It can detect the UI. It can get more hungry, less happy, lose energy. We can also feed it, send it to sleep so that it regains some of its stuff. And we can start a minigame that is not there yet. And we also have the UI for the minigame. If we go here and deactivate the normal UI, we can activate the minigame UI, which lets us do many things over here. And basically we have a fully working minigame, virtual pet prototype made in Unity already. So in session 4 we're gonna complete this prototype with a little feature that I really want to implement, because it's customary now in all virtual pets that you may have or may want to, you know, play in your phone or whatever. You have this functionality, which is the minigames. I want to be able to click on this button, pop up a menu, and see a list of minigames that we can play and work with. And then this minigame, we already have the wrapper, but I'm gonna prove that our wrapper allows the player to do, or rather the developer, to create minigames and adapt them without any issue. So that's what we're gonna be doing. We're gonna be in 4.1, we're gonna be defining what minigame we'll be doing. It's gonna be a very simple minigame. Then we're gonna be coding it and adding it to our game. We of course have to, probably in minigame definition, I'm gonna do a slight amount of coding because we're gonna need a player, but maybe in 4.2 I can do everything, I'm not sure. And then we have 4.3, which is also for finalizing and fixing the minigame if there's any need for fixing, or I want to add something else. Maybe it will all depend on how the session 4 4.1, 4.2 progress. So if they progress correctly, 4.3 is going to be really short, just talking and adding some small lines of code. But if 4.1, 4.2 go really hard, then of course we're going to have to fix stuff in 4.3. So that's basically what's going to happen. We're going to create this small mini game to add to our wrapper as a very simple example. So yeah, I appreciate you guys for watching. I hope you guys are having fun, learning a lot. If you guys have any questions, remember you can reach me through email or through the website. So I'll see you guys later. Hello everyone, welcome back to how to create a virtual pet game in Unity. This is session 4.1, which is called minigame definition. We're going to be defining the minigame that we will be creating, and also I'll be creating just a few base scripts to save some time. So the first thing that I will do is I will define the minigame that we'll be creating. It's going to be a very simple minigame. We will use the same whiteboard as before. We're just going to accumulate this item over here so they become, way smaller. And now we can talk about the game. So basically the minigame is going to be a 2D game. It's just going to be a small minigame. We're going to have a window, a little square, of course our camera, and we're going to have a floor area over here, and we're going to have a little pet, which is like, this head thing. I'm just going to make it a square. That didn't work. Okay, so this is the ears, and we're going to have a little platform over here. We're going to have another platform over here, and then a final platform over here, or something very simple. Not even sure exactly the way that we will do it. And then we're going to be jumping with the creature over here, and we're going to be grabbing some item here to increase our score. Then we're going to have to jump over here and grab a second item to increase our score. This is our pet over here, and this is the second item. I'm going to put a number 2 here. And then finally we're going to be jumping on the third place over here, where our pet is going to grab the number 3 item, and it's going to be winning the game. Well, as soon as the pet takes this third item, it will win the game. And there's going to be a timer. It's going to be maybe 30 seconds. So if the timer goes below the, it reaches 0, it reaches 0 here, we will of course lose the mini game. And if it doesn't reach 0, if it's just going for, the person is able to do the 3 jumps, is going to be able to grab the thing. So there's a chance, depending on how long, because of course I have to code this guy, I have to code these guys, and I have to make sure that everything works just by tapping, click on the little controller button, and remember we have the pause button over here. So we're gonna move with WASD, or rather with A and D, and then with spacebar we're going to be jumping. And my whole point here is if I can build this real quick, I might add some enemies, and the way the enemies will work is just be a killing thing. So it's gonna be just like the little spikes here and there, maybe a spike here, I don't know, I'm not sure, or maybe a fireball that like moving from here to there, so that the player doesn't have too much of an easy time when playing this game. We want the player to feel challenged, although since this is a virtual pet game, the target is probably young males or young females, very young players. So we do perhaps want to allow them to have a little want to have a little lenience. So after the minigame, when we finish the minigame, we'll show the victory screen. We will reduce the amount of energy, and we will increase the amount of happiness that the pet has. And this is basically the base minigame that we're going to be creating, the example minigame. If we have enough time, which I think it's going to be fine, for session 4.3, which is going to be finalizing and fixing the minigame, of course, we might also add some sounds, like a jumping sound, maybe a grabbing the coin sound. Maybe we'll add a little music to this area, and then a different sort of music to the main room area. The whole point is that we make the most of this tutorial series so that we cover all the grounds that we can on the series. Right? Basically, that's the objective. Have as much learning as we can. So I'm gonna be creating a few controllers. I'm gonna go to my scripts, controllers, and I'm gonna be creating a minigame pet controller, because of course our minigame, our pet cannot be exactly the same as the one we have out here, because of course, as you know, this guy is not mobile or anything, so I might just include the minigame pet controller into this guy and then use both, just one at some times and another one at some other times. We'll figure that out with a manager later. The other thing that we need is this minigames controller, because we have the base minigame controller, but now we need our first minigame controller. I'm gonna call it test. So I'm gonna be calling that the pickup controller. That's good. And the other thing that we need, as I mentioned before, probably is a spike controller, or rather enemy controller. So I'm gonna call it a base enemy controller. I'm not sure if I'll get there. And also we're gonna go to the managers, because I want to do one more thing. I want to create a sound manager. I'm gonna call it the sound music manager. This is, again, in case we have enough time, we will run and create a sound music manager to have music in our pet area and have a different sort of music in the minigame gameplay area, right? So that is going to be the gameplay for this, and it's gonna hit OK here. So we have a very simple gameplay over here. We're gonna have something very cool, very quiet, very relaxing sort of small mini game. There's no issue here with creating a simple mini game, because again, we're testing, and also Tamagotchi game is about the Tamagotchi, not about the mini games. But this will help. This also always having some sort of interaction helps with the player engagement. So just to do a small thing here, I'm gonna go into the sound music manager, and I will make it into an instance just for fun, just to do some coding, because gotta get warmed up, gotta get ready for the coding that's gonna come up in session 4.2. I'm gonna do the little instance here with this guy. I'm gonna do a public static sound music manager instance, and we're gonna go into our minigame UI controller, which we know is an instance, and we're gonna steal this little code here and modify it to suit our purposes into our awake function. So we have it here, and we do sound music manager. We don't want to have more than one sound music manager in a whole scene, of course. We don't really want to have too much control, too much to think about this size. So I'm gonna also do a public audio source, and it's gonna be an array of audio sources. It's gonna be the audio sources, of course, and we're gonna have a public array of audio clips, and this is gonna be the music and the SFX. I'm gonna be checking out the assets to store some music and sound effects to implement later, but this is a basic sound music manager that we have here. I'm not gonna be touching the other scripts too much, but I'm just trying to do some stuff in this. So I'm gonna go to the base enemy controller, and our base enemy controller is a guy who will have a collider, and this collider will be doing something interesting, very simple. So I'm gonna do on collision enter 2D, which, because this is a 2D game, we will be doing a check. If the one who collided with this guy is the player, then we lose the minigame, basically. So I'm gonna do if collision that collider that compare tag is player, we will say, and we're gonna talk to the minigame UI controller that instance that finish minigame, and you see that this guy needs to pass the score and the time remaining. So that is, of course, not necessarily a wise choice of how to end the minigame. So what we do is I'm going to do collision that collider that get component. I'm gonna get the component player, which is gonna be my pet minigame controller. Oh, apparently that's not in pet. You pet manager pet. Where's my minigame? There you go. Pet minigame controller. And the pet minigame controller is going to be sending the signal that the minigame is over. But as you know, this is also here in the base minigame controller. So yeah, goal reached, finish minigame, score, timer. Well, maybe if you die per by enemy, then you just don't get anything, right? Yeah, that's actually a good idea. So I'm just gonna change the code a little bit for ending the minigame. So I'm gonna be going for the minigame UI controller, finish minigame, but I'm gonna have a new void. Actually, I'm gonna call a new void. I'm gonna call it public void lose minigame. Of course, this is not gonna be implemented yet. Not ready. I'm gonna go to my base enemy controller, and this guy is gonna call the lose minigame method. Of course, the lose minigame method, I'm gonna go into my minigame. I'm gonna just set the minigame end UI to be active, and it is interesting because simply when you activate this guy, nothing is really happening. The minigame end UI, this is navigating to the definition of set active. So the minigame UI, even when it gets activated, it's not really doing much. But what's going on for real is the fact that we want the minigame UI to ask this guy whether the game is lost or not. So I'm gonna create a public bool victory, and we here will say that victory is true. Here we'll say that victory is false, so that we have the data in our minigame UI controller basically. I'm gonna go to my base enemy controller again. So my base enemy controller, the only thing that it will do is if collided with, the minigame will be lost. That's all the base enemy controller needs to know. At least for, and of course this is the base enemy controller. I'm gonna actually call this a protected virtual void, just in case we do go for a special sort of enemy thing. If we do get some moving enemy, we will want probably to override that behavior. And yeah, so how's the minigame? Well, I define the minigame behavior wise. I mean, yeah, the behavior, but I want to define it code wise. So how are we gonna generate the minigame? The minigame will be generated by via prefab. We're gonna get a prefab of the minigame, and as soon as we click on the minigame button over here, we will spawn that prefab and we'll place our guy in a specific point in the prefab, and we will change the size of the camera to be larger so that it can cover the whole prefab. All these things are going to be gone because we're going to be seeing I'm going to show you the minigame UI instead of the pet UI. So it's going to switch to this, and when it switches, we will see that this guy is moving. It's going to feel like he's smaller, but he's not going to be smaller. It's just the camera has a different sort of size here. And then we will play the game. I don't know why this is getting saved like that. And after we play the game, when we call the minigame finish UI, which is this guy, the minigame end UI will get, I'm gonna go here, create C# script, minigame and panel controller. So our minigame and panel controller is going to be getting the information about what happened. It's going to be initialized basically. So I'm going to go here, and this guy, I'm going to create a little public void initialize, and of course we need references to the text here. So I guess I hope we don't have any reference to them here. We don't. Okay, good. I'm going to change this minigame UI and UI to be a minigame and panel controller instead of that. And here it will say dot game object, or rather I'm gonna say initialize, and we're gonna initialize it with the score and the time remaining. And I'm gonna do the same here, so I'm just gonna initialize it with the score and the time remaining. Oh, we don't have the score, really? Oh, we do. I mean we can have it. So private score, private int score, and private float timer, or rather time remaining. And we will, every time we update these things, we're gonna say time remaining equals timer, and here we'll say whoops, I will say score equals score, and of course Unity is gonna complain, so we have to say this as score, and here we can send score and time remaining like this. And we're gonna right click on this, go here to the left, we say add parameter to minigame and controller initialize, but you can see that it only says score, so I'm just gonna go to my initialize function and I'm gonna say in score float time remaining. I'm gonna delete all of this stuff, and I ended up coding more than I thought I would, but that's fine. It's good to save time. We did need to do this sort of thing. So now that we have this part, we will say I will actually add a public text. Okay, so we need, of course, we need using Unity engine.ui. So now we'll have a public text. It's going to be the score text, then the timer text, and then we will have to say that our score text is going to have a specific text, and also we need one more thing, and the thing that we need is the bold victory. We need to know if the game was won or not. So actually in my base minigame controller, or in my minigame UI controller, I will not store the victory because I of course don't need it, but I will send it to this guy. So I'm gonna say true, and in here I'm gonna say false. So what's up with this? There's one thing here, so we're gonna say time remaining is more than 0. So if time remaining is more than 0, then this will be true, and that means there's a victory. But if the time remaining is less than 0, then no. Then it's gonna be, of course, false. So I'm just gonna save my changes. I'm gonna go to my panel, and we have this sort of thing. I'm gonna add one more text, which is the title text. And I'm gonna be doing this stuff. I'm gonna say that my score text.text will be equals to you obtained points, like this. Then this is wrong because I forgot to add string.format. We have to do comma score. Then we will do about the same thing for all of the other ones as well. For the next one, which is a timer text, you achieved you had this amount of seconds left, and there's gonna be time remaining like this. And finally, for the last line, this is gonna be our title text. .text is gonna be depending on the victory thing. So victory, and then we will say you won. And if you lose, you will say you lost. That's it. This works like this. So basically, we're asking. This is like a if statement. So we say if victory, if we win, then you won, if the victory bool is true. else, this double, like this column means else you lost. So it's quite straightforward. It's something that you can work with at any time. You won or you lost is basically what we want to do. So that's basically our minigame and panel controller. So we have to initialize it every time. And the other thing that we must do from the panel, the UI control thing, is we have, of course, activate it. So minigame and UI still needs to be activated. So minigame and UI, that game object that set active is true. Sorry for that. Then there we go. We double click this and we add it like this. So good. We are sure that this will work. So you could ask yourself, why am I passing in the score and the time with the finish minigame thing? So I'm passing it in here because when I want to have very precise score and time when I win the minigame. But if I lose it by just because the thing hit me, the enemy hit me, I don't really care that much. That's just the way it works. So we do have the result, the title, and okay, so apparently the result. Okay, so minigame and UI is this. We go here. The result seems to be defined in only one text, which is fine. So I'm gonna just switch the way that I do it. I'm gonna go and delete this to be result text. And so I'm gonna mix these two things. I'm gonna say result text, dot text. I'm gonna delete this. I'm gonna copy this part. You obtain 0 points and you had, I'm gonna delete of course this thing and this thing. You obtain 0 points and you had 1 seconds left. We delete this. I'm going to move the string.format down so we can have a little more visibility here. And we need time remaining here. So this is the way where you do it a little longer. So you have you obtain a certain amount of whatever. So this is like the first parameter, and then you have this is fine, 1 second, one whatever amount seconds left. So we have score, which is the first parameter, this one, and we have time remaining, which is the second parameter, this one. And then the title text will change accordingly. So now that we have this fixed to be a little more consistent with what we had built before, I'll wait until Unity finishes calculating. So we will end result text, title text, and the other thing is we can add something else here, which would be the happiness calculation, but I don't think that's actually necessary. I thought before that it would be necessary, but it's not. I honestly don't think it is necessary. Okay, so we can't, of course, we cannot test this result because the way that our game works, we need the minigame to be working first. So what I'm gonna be doing is I will advance onto the next tutorial in this video, and in the next video we're gonna code in this behavior, and then we will of course hook in the stuff that we just got done, so that we are able to see the result live in our minigame. So yeah guys, thank you for watching. I'm gonna do a small recap of what we did, and then I'll just cut the video. So if you guys have any questions, remember you can ask on the website through email or anything that you may need. So what we did was define a minigame. We have our little diagram here of what the minigame is going to be, and I coded in the minigame and panel logic so that it shows results and decides whether the game has been won. And also I added a base enemy controller that if it gets collided with, it will lose the minigame for the player. So in the next tutorial we have to code in a lot of stuff, so I hope we have enough time, but that's why we have 2 sessions for that. So see you guys very soon. Alright everyone, welcome back to how to create a virtual pet game in Unity. This is session 4.2, which is minigame, coding, and adding. So we have to start with this. What is it that we have to do? Well, the first thing that we must do is we have to create the minigames environment for the pet to work in it. So I don't know what this keeps happening. There we go. So what is going on here? What do we have to do first? Well, the first thing is create the level. I'm gonna go ahead and close this guy, the background, and I might actually even move the pet away just so that I can not have this massive thing as ruining my frame of reference. And I will make the I will not do that. I'm gonna keep this guy here, and I'm gonna click on my camera. I'm gonna see how big I have to make the camera so that the game, so that we can get a good amount of space for the pet to play in. So 10 is too small. 15, whoops, not that. I want to move the pet, not the camera. I want the camera to always stay at 0, 0, but I want the pet, of course, to move, say, over here. So here maybe we can jump on something here, and something here, but that's still too small, so I'm gonna make the size 20, and I think that is actually fine. Let's go here. I'm gonna go back to our main camera, to a game here, so we see that the pet's over here. Yeah, this should be enough space, so I like this size. We have to memorize size 20. We will now go to our minigame. Minigame control. We don't have any control, okay, so we'll go ahead and create this test minigame. And our test minigame will have a test minigame controller. And our test minigame controller doesn't have any code in it, so we have to start working on it. And this guy will be inheriting from base minigame controller, which will give it already some powers. The base minigame controller, I'm gonna add something else. I'm gonna add a public int, or rather public float. We already have public float field, so I'm gonna do a public float, and I'm gonna call this float the camera size. So here we will go ahead and set our camera size to be 20 so that I don't forget. So whenever we start the minigame, we will change the camera size to be that. So what about the timer? The timer is going to be 30. All right. So what else do we have to do here? So the next thing that we must do in our test minigame controller is get a reference to the player. So rather, not really. So we will only have one player, of course, right? We will have a pet minigame controller here. That's the only player that we'll have. So I'm gonna add a pet minigame controller, minigame pet controller over here. And we will also add a box collider 2D to our pet. And you can see that the box collider is very small. And that is because it's not in the object that has the right size and stuff. So it's fine. We can still work with it. I'm just gonna make it so that this box collider is a little larger. We're gonna make it so that this box collider does this. I don't want it to be all the way up, so this is fine. And we also have a rigid body 2D. And I'm gonna apply this. But our rigid body 2D is not gonna be simulated. As long as I don't need it to, so that when we hit play here, we don't actually base minigame controller that change timer. Oh, of course. So this has to be start. This has to be on start because I'm gonna be using the minigame UI controller that has not been set if I do it on awake. Okay, so good. The next thing that I want to do is make sure that change worked. Okay, good. Let's play again. And there's another null ref. Minigame UI controller dot instance dot update timer. So we will say we will check out why that's happening. Oh, that's happening because this guy is of course not on. Okay, so we'll go ahead and go to our guy again, our base minigame controller, and we'll just do something very simple here. We're gonna say if minigame UI controller that instance is null, then we just don't apply any changes, we just stop there. There we go. So we're gonna go that in each of these changing things over here. So there we go. So that way we make sure that at the start of the game, if this is happening, then we don't get anything weird going on. That it should never happen, honestly, but you know, just in case. I'm gonna go ahead and play again, and we have our pet, and you see that it's like traversing life for some reason. It's moving that way and here and there. Okay, so I do know why it's moving. So it's moving because of my pet controller, right? So if I turn this off, it will stop moving, and that's basically what we want to do. Whenever the minigame pet controller is active, we want to deactivate the that guy. So we're gonna say on enable. I'm gonna grab our friend. I'm gonna get component pet controller, and I'm gonna do dot enable is false. So whenever this guy gets enabled, the other controller gets disabled. So basically we're just changing modes between the minigame mode and the normal pet mode. So we will see here when I start the game that if I hit play here, I mean if I activate this, then this one gets deactivated, and if I deactivate this and activate this, this guy will resume working as normal. So minigame pet controller, we're gonna need a reference to this guy in our minigame UI controller. So I'm gonna go to my minigame UI controller. I'm gonna find a reference to my public minigame pet controller. Minigame pet controller, and whenever this guy is enabled, we will activate the minigame pet controller. So minigame pet controller dot enabled is true. And whenever this guy is, well, not really, I'm not gonna do that, I'm not gonna do it this way, but whenever I'm gonna do it with this guy. So I'm gonna go to minigame and UI, and when I say on disable, minigame UI controller dot instance dot minigame pet controller enabled is false, and our minigame pet controller, whenever it gets disabled, so on disable, it will go ahead and say get component pet controller enabled is true. So that way we're sure that they're gonna be one active, one inactive every single, like all the time. Our minigame pet controller, what else does it do? So we need a bit basics for movement. So we need a public float speed, public float jump speed, and we need a private rigid body 2D, which we're gonna call R2D, and we're gonna need a, that's it, brother. I think that's it. Okay, so how's it gonna work? So on enable, we're going to be saying R2D equals get component. You know, if it's null, we're just gonna make sure that it exists. So we're gonna get component rigid body 2D, and then we will say R2D.simulated equals true. That will activate our rigid body properties, right? So we will be moving or something, I mean, depending on what we require. And we're gonna wait a little, just a little smidge. I'm actually gonna save my pet so that all these changes are saved. So what's the speed? I'm gonna play with 10 and 50 for jump speed. And we're gonna do the input part. So I'm just gonna do update if input.getKey keycode.w, or rather a, which is left, then our creature will move to the left. I'm gonna say move move in the directions -1, I guess. We could just do get axis. I'm gonna do get axis. So get axis. So what's the difference? Get key is 1 or 0, while get axis is key code. I'm just gonna do check movement. So checking movement is going to be very simple. It's gonna be if input that get axis horizontal is more than 0 or is different than 0. So if input that get axis horizontal is different than 0, we're gonna do R2D that add force speed that time that delta time by time that delta time, and we'll also multiply by the direction, which is gonna be this value. So if we're using the left or right arrow, what are you complaining about? Float to Unity engine vector 2. Of course, we're only adding the force new vector 2. We're only adding the force in the horizontal because it's, of course, you know, a horizontal thing. So we're just adding vector 2, which is the speed multiplied by time but delta time. This is for us to be able to pause without making too much fuss. And then the keys are going to be the horizontal keys, and the way that you check what are your horizontal keys are is by going to edit, project settings, input, and you can click on axis. And you can click on horizontal, and you will see that it's left, right, AD, and you see these things that are for you to work with if you need to work with them. Okay, so the next thing that we must do is check out these things. There we go, check movement. Okay, so that's check movement for horizontal. So I'm gonna do check horizontal movement here. I like having the right name, so this is only for horizontal. And I do want to have an input if input that get key down, and I will say key code dot space. We will be doing jump. We don't have a jump method yet, so I'm just gonna create it. And jump is just the same as this. I'm gonna add force vertically. So I'm gonna switch this. I'm gonna delete this actually, and I'm gonna add it over here. I'm gonna say jump speed multiply that time by time the delta time, and that is my jump. So the other thing is we need to make sure that we don't double jump. I think at least for now I don't want to double jump, right? So the way that you do that is by having the collider know when you're grounded. When you get in contact with the ground, then you are grounded. That's basically it. So I'm gonna have a private bool grounded, and we will say, we'll grab here and say on collision enter 2D if collision that collider that compare tag. So compare tag. So if the other guy's tag is ground, then we will say grounded equals true. That's it. And then on collision exit, which means basically when we jump. So private void on collision exit 2D. We'll say the same stuff. We'll say grounded is false. So there's a few problems with this. You can probably imagine that, but I think it's fine for this game. Basically, you know, this is not a tutorial on how to make a platformer, but basically when you touch the ground from below, you will also activate the collision. So I think you can do something like collision dot contact point or something, contact. Yeah, you can check where the other collider is compared to you. So if it's lower on the y-axis by a certain margin, I'm just gonna show you here. So if collision.compare_tag is ground and collision.transform.position.y is less than transform.position.y, then you know that the collider is below you. But there's a big but here. You have to know the height of your player. So I'm gonna go ahead and show you how to know that. I'm gonna go to my collider here, and we see that the collider size is 3.55 in Y. So you know that this is not like perfect because I didn't make it perfect. I want the offset to not exist, and I want to get the collider to be more or less the right size, right over here. So we know that our height's like 4.4, maybe over here 4. Yeah, I think 4 is a fair assessment of our height. I'm still not gonna do it like that, but okay. So our height is 4, so we need to have the other guy to be at least their position +2 has to be less than our position, because that means they're actually below us. There's no way that they are their position +2 and they're still above us or in the middle of us. So this could get quite messy. I will try it, I will leave it in, but I'm not sure that this would work. So if it works on the first try, again, I know that it will work. It just needs some fine-tuning. If it works in the first try, then we're good. Okay, so I'm actually gonna do 1.5F just to be a little more, have a little lenience here, a little more safety space. Okay, so now we need the ground, right? So I actually need the minigame to exist. So I'm gonna go ahead and have my test minigame, and my test minigame I'm gonna add a sprite to the object sprite, and we're gonna call this ground. And again, I have to create an object that's gonna be level or ground objects. There we go. And so my ground is gonna be inside here, and they're both going to not be on that place. No, I want my test minigame to be in 0, 0, 0, of course. And my ground objects also must be in 0, 0, 0. So my ground is gonna be all the way down here, like on the bottom. And we're going to also have I'm going to create another object. It's going to be called spawn and starting points. There's going to be an array of starting points for the player. So I'm going to create a few starting points. So I'm going to be creating a few objects. I'm going to have one here. I'm going to move it over here. And over here. So 3 starting points for our player. And now the ground object, we're gonna add a new sprite. I don't think I have ground sprites, so I'm just gonna use whatever sprites I can. I don't have a tile set here. Maybe I should get a tile set. Okay, I'm gonna go to the assets or whatever, and we're gonna find a very small tile set just to use. I think I have one of my favorites, so let's go check it out. I don't know what this is. I'm gonna go to my assets. I'm gonna group them by nothing. I'm gonna be checking out tiny fantasy icons, K-Pathfinder, tween, blah 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 blah. We are going to find what's this default plus shader? Okay. Unity, TouchScript. I don't think I have any. Wood texture floor. Is this free? Let's check it out. Yeah, it's free. So we're gonna go to wood texture floor. Let's see what this has. It has a PNG, which is all we want. Okay, so we're gonna go to wood texture floor in the asset store. We're gonna download this. I'm gonna import it, and we're going to import again. We're gonna move this guy to our art folder. How? I have no idea because it's all the way up. So I'm just gonna drag like this. Okay, so now we have a wood texture to use in our ground, which is good. We also have to change the tag. We have to add the tag ground. You hit on add tag, and on the list you click here and you write down ground. And now our ground objects are gonna be tag ground. We're gonna add the sprite first. We're gonna add the wood texture here. We can't. Why can't we? Oh, we can't add the texture. What? Okay, we cannot add it because it's not a sprite. So we go here, edit, blah 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 blah, hit apply. It's not gonna be important. So we're gonna do that. We're gonna remove this thing. I want to remove this. Reset. There we go. So we can see that it actually doesn't seem to look fine. Oh, it does look fine. It's just too dark. I don't want to have any of these things, so none. I want it to be sprite standard, UI, sprite default. There we go. So we now have our little ground object, and I don't care about looks, so I'm just gonna do this. And we see our starting points are, I'm gonna be setting the starting points with this little blue diamond so that we can see them in the scene. Blue diamond, and I think we can see them. Yeah, if I get close enough, I can see where my starting points are. Just we don't want to, interrupt my starting points with anything. And now we have the ground. We will duplicate this guy, and I'm gonna move him over here, and I'm gonna of course reduce the size very much. I'm gonna move him like here, so it's a little platform. It's good. And I will just duplicate this and add another one here, duplicate that, another one here. And I'm gonna increase the size of this one to be a little interruptive. And now we'll add one more, and I'm gonna put it like on the right. I'm gonna go and check out how it looks in game without the pet UI, more with the minigame UI, and that's good. The camera is not gonna follow the player at all. So what I'm gonna do is I'm actually gonna move this a little down, and I'm gonna make it a little shorter. I'm gonna move this other guy a little down too, so that our player can fit in without touching the UI too much. And now we need the pickups. So I'm gonna create a new object. I'm gonna call it pickups. And I'm gonna create another sprite. So I'm gonna go to 2D object, sprites. I forgot to add the colliders to this guy. So you just select them all, go to add component, and say box collider 2D. Now they all have colliders appropriately. And I'm gonna go to the new sprites. I'm gonna be calling it pickup. We're gonna have it over here, and we'll set the sprite to be, maybe we have to save the rabbit, so that's our sprite. I'm gonna add the component box collider, set it to trigger, don't forget, and I'm gonna have one rabbit over here, I'm gonna have another rabbit over here, and I'm gonna have a third rabbit over here, and all of them will be a different color. I'm gonna go ahead and select only one actually. I'm gonna select this guy is gonna be a little red, this guy is gonna be a little blue, and this guy's gonna be the natural color. So that way we have our pickups. And I'm gonna add, of course, to all of them, I will add the pickup component. So we create the pickup controller component. And so what's the catch? So why is it being so easy? Well, it's not. Don't worry, it's not gonna be that easy. Okay, so I'm gonna click on play. Oh, oops. I don't click on play yet. Yeah, this is gonna be issues. The first thing is I need to save as a prefab. I'm gonna save my test minigame as a prefab and delete it from here. That way it's good. We're gonna see what the hell. Initialize basic controller. Okay, so it's complaining. The game is complaining because the pet UI is not on. And again, the other thing that we need to do is check how this is happening. Okay, so probably the needs should also be turned off. Yeah, whenever we play the game, we will turn off the needs controller. So get component needs controller. Okay, I'm gonna enable it when I disable this. False. And I'm gonna yeah, this is what I meant. True, true, false, false. There we go. Maybe that will work. We will see. We'll probably have to correct it or whatever, but we'll check it out. So we have our probably working minigame system. There's one more thing though. We want the camera size to change, as I mentioned before. So whenever the minigame UI controller gets activated, is that you? Who is the one who has the? Let me check. Oh, it's the minigame. Oh yeah, you. The minigame UI controller must have the prefab for the minigame. So I'm gonna do public game object minigame prefab, and we're gonna go ahead and wait a little bit and assign the minigame prefab to my minigame UI. We have the test minigame, there we are. So of course, if you have many minigames, you just have to implement UI to select them. I would recommend that you check out my tutorial, how to create an RPG in Unity, a top-down RPG in Unity for inventory. I have options for this sort of stuff. Also, I have the best practices in UI. So yeah, there's a lot of things. Okay, so whenever we enable this, we're gonna instantiate. We're gonna say game object minigame equals instantiate minigame prefab with no parent, and we're gonna be moving that prefab. So minigame.prefab.transform.position equals vector3.0, so that we have this guy spawn like exactly as I designed it to spawn. The other thing that must happen is we need the minigame pet controller, so the pet to move to wherever, to one of the spawn positions. So how do we do that? We do that through the minigame object. So the base minigame controller, actually, I'm gonna go ahead to my base minigame controller. It lacks something, which is a public transform array. And this transform array is going to be the starting positions. And whenever this guy gets enabled, so on enable, should it be on enable though? Maybe on start is fine. So okay, so what's the point? What's the problem with this? So I'm just gonna do an initialize. So public void initialize, and what this will get is transform, and this transform is gonna be the player, or rather the pet. And we're gonna say pet.transform that, or rather pet.position equals starting position that position, and we'll decide this by random, of course. So I'm gonna do random.range from 0 to starting positions that length. We will be what happened here? We will be choosing one of those positions at random and assigning the pet to be there when the minigame starts. So that's basically going to be moving the pet to the right position at the right time. So the pet will be positioned correctly. So we're gonna go ahead into the minigame UI controller, and we will delete this line. Actually, I'm gonna say minigame.getComponent base minigame controller, and we're gonna initialize with the pet transform, with the minigame pet controller that transform. And in initialize, we will set our position, this guy's position, to be transformed that position equals vector3.0. Okay, good. Okay, so you see that the minigame pet controller has not been set, so I'm just gonna set it here. This is this guy. And also, who is the one with the camera size? The base minigame controller. So this guy is also gonna change the camera size. So on initialize, I'm gonna say that camera.main equals the orthographic size, sorry, orthographic size equals camera size, and camera.main, this means just the main camera, that transform that position equals vector3.0, because that's the way that I set up the minigame. Okay, good. And the next thing that must happen is whenever the goal is reached and we're going to destroy the game object, we have to reset the camera again. So camera.main.orthographic size equals 5. That's my base camera size. And again, we're gonna reset the position to be 0, just in case whenever we transform that position. So just in case when we change the size, the camera's position changes. So sometimes Unity just adjusts the position depending on where the size of the camera and all that sort of stuff. So, you know, it all depends. So, okay, we have our stuff over here. Our pet should have the minigame controller off. And I am praying, pet UI controller, that this will work. Okay, I'm gonna hit Control S, and here we will test. That's why we have session 4.3 to fix any issues. Okay, so first thing, I forgot to set the camera back to 5. Was it 5 always? Oh, let's actually check that out. So I'm gonna move the pet here. Yeah, it's always been 5. Okay, so that is our pet moving and stuff as normal. There. Click on play, and we have the first problem. Index out of range. So why is the index out of range, you may guess? Well, I forgot to set my, I'm sure that's it. I forgot to set my starting points in my test minigame. So I'm gonna go ahead and, as I said, yep, I'm gonna go ahead and set them. So I'm gonna lock this, and I'm gonna be grabbing all of them by hitting shift and dragging, like selecting the first and the third one, dragging here, dropping, and then applying. Now I delete my test minigame, and it's unlocked by default. So I'm gonna hit play again. Now we hit game, and we will see what's up. So what is the problem? The camera is not seeing anything because of the clipping plane. So I'm gonna hit 0 here, and you will see that this will all be visible, but I'm gonna make that permanent. So 0. That's because I'm setting the Z position. I'm just gonna do it correctly. The Z position, I'm setting it to be 0, and that's not right. The real position here should be new vector 3 0 0 minus 10. That is the right position for the camera actually. So I'm gonna copy that and do this here and test this again. Click play. Test. So I want to check. I can't move. I'm trying to move and I can't. So I'm going to check my pet. I'm going to see if or why this is not moving. Can I jump? No. Can I see if it's grounded? No. So I'm going to be making the bool grounded public just to be able to see it, of course. Move this up. And we will see why this is happening. I'm gonna add way more power to this. I'm gonna make it be 150, and I'm gonna make this be 500, or rather whatever, 5,000. If it jumps, it jumps. Good. I would just need to prove that it's able to jump. I'm gonna go here. We can jump though. So what if I set this to be 1500? Oh, that's the problem. We are too large. Whoa, 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 whoa. And also this is too small, so there we go. So we can hit jump, whee, and we can grab this guy over here. Well, we can't yet, but so we, as you see, the game is over. Minigame pet controller is still trying to be checked. What does it say? Has been destroyed. Oh, yes, you should not be destroyed. Who destroyed the pet, though? Probably the minigame UI controller. Yeah, it probably destroyed the pet. I did see the destroy a little bit ago. Base minigame controller. I want to see all my destroys in the project. Nope. Effective 12. It's gonna be navigating to the definition. I'm gonna right click, final references, and nope. Okay, so whatever. This guy's getting destroyed for some reason. I need to know why and where. Minigame UI controller, base minigame controller. Is it the main? There's someone, I do remember that I did that. So final references, initialize. I'm not sure what happened. The object type minigame play control has been destroyed. We'll figure it out. So the first thing that I want to do is make sure that the pickups are being picked up, and also my pets. This is like way too low, as we said before. So I'm just gonna set it to be the right amount of power for moving. I want to have some in my rigid body. I do want to have some linear drag. I want to set it to 5 because I felt that I was accelerating too much. So I'm gonna go here, click, and yeah, we can move better. We can't jump enough. Also, there's one more thing. I want my, whenever the pet jumps in general, I wanted to say that the grounded is false. That way, I'm making sure that I can't, I just multi-jumped and I don't like that. I could just change, I'm gonna change this. I'm gonna change this to be 5 and this 1.5, not F. I'm gonna hit apply and we're gonna go to our jumping part over here, and we will definitely just multiply by 10,000 or something. 5,000, and jump also, where's jump? Jump speed times 1,000 or 10,000. I think 10,000 is actually the right number. Okay, so trying to balance a little bit, but I have to check my pickup. Controllers, pickup, there we go. Oh yeah, the pickup controller doesn't really have anything, so on trigger enter, these guys are triggers, so on trigger enter 2D, if collision, or rather collision, that compare tag is player, then we will announce that this was picked up. We will announce to the UI, so minigame UI controller, that instance that increase score, change score, update score, and we'll update score by, oh wow, that's very dumb. Let me just go check. So who is the one in charge of that then? Minigame controller, basically, I guess. Base minigame controller, update, change time, change score. This guy is the one with this power. So I guess the player is, but why would you be, no, this makes no sense. This guy should not be the one in charge of changing the score. It has to be the UI. So this code should be in the UI. Well, not the timer. The timer should be, yeah, the timer should find that it's here, I suppose. No, it's not. The minigame should not have the timer, should have the max timer. Yeah, the score is the one thing that I would change. So I'm gonna change this. I'm gonna move the change score thing. Again, it's not being used anywhere. So I'm gonna go to the minigame UI controller and I'm gonna add it here. So this is gonna be a public virtual void. Of course, this makes no sense, but this makes sense. We're gonna update the score with a new score. That's it. There's no way to run away from this. And now we go to our pickup controller and we will say change score 1. There we go. And we will then destroy this game object. There we go. We're destroying the pickup whenever we collide with it, basically. Okay, so we wait a little bit. Okay, so I will hit on my minigame, move this. We can still multi-jump for some reason, but I don't care too much, and we cannot collide with this for some reason. Why can't we? Well, there's another thing. I want my rigid body to stop rotating. I'm gonna freeze rotation. And this guy doesn't have the tag player, that's probably why. So I'm gonna hit apply, hit play again. So give me a second here. So we have to test this. I'm gonna hit play. I'm gonna grab this, I'm gonna move. Well, we're fine pick, it's fine. Okay, there we go, we have score 1. Score 2. Minigame of the flying pick, score 3. So we have the final score, it's 3. So what's gonna happen here? I'm gonna adjust the system a little bit. I'm gonna grab my minigame controller, and whenever it starts, I'm gonna send a signal. I'm gonna tell the minigame UI controller what my goal is. So I'm gonna say private int. Well, not really. Base minigame controller initialize, change score, daytime, finish minigame. Who finishes the minigame? Okay, that's good. Okay, so the one thing that we are lacking to finalize this part is go to the minigame controller, and we must end the game. It's not getting finished. So when are we gonna go reach? We're gonna go reach when all 3 pickups have been picked, when our score is a certain amount, when our score is 3. So you can see that this function actually shouldn't go here because we're not keeping track of the score in the game controller. The game controller is just only changing the timing. Of course, there's different structures of code that you could do, but for this sort of quick, very quick, I'm doing this in less than an hour, very quick minigame sort of systems, this we can just do it. So I'm gonna go into my minigame UI controller and I will say if score is more or equals to 3, then I'm gonna say go reach. And my base minigame, I'm gonna steal this code from this guy. Well, kind of. Also, I need to keep a reference to the minigame here. Okay, so goal reached. I'm gonna create a new void here, like this. I'm gonna paste this, not this. I'm gonna be finishing the minigame. Or rather, I could just do finish minigame, right? Yeah. I'm gonna do finish minigame here. Minigame, and I will pass in the score and the timer. There you go. And we have that, and I will add this to the finish minigame object over here. And in both cases, I will also add destroy the minigame. So destroy minigame, and say again destroy minigame. There you go. And that should lead us to the result that we want. Okay, so let's try that a little bit here. We hit play. So we get minigame. I'm gonna go here. I'm gonna go try to get the 3 little bunnies. Oh, 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 whoa. What happened is I think the gravity is too soft. Okay, you won, you obtained 3 points. I had 16 seconds left. Go home. And when we go home, we have to set the pet's position to be 0 again. Like this. So I'm gonna hit play and he's over here. And so yeah. The other thing that we must do when the pet controller is off. So on disable, there you go. We're gonna say that the rigid there you go, and then we will say that the transform that position is also vector 3.0. And the other thing that we need to do is say that the R2D that simulated is false again. And I think that's basically it, so we'll check it out. I'm gonna wait just 1 second so that this loads. Hit play. And okay, we'll hit play here. We'll jump. Get this. Yeah, this is actually really fun. So we get that, and then we get this. You have won. You had a certain amount of seconds left. We go home, and we have our little player, our character, our little pig behaving correctly. Okay. Woof. So that is the minigame, the base minigame controller. This is our basic minigame thing where it's good. So we have the minigame with the minigame wrapper, and we have a minigame to test that it actually works, and it works perfectly and correctly. So I'm gonna do a small recap now. If you guys have any questions, you can ask me through the website, so through email, so whatever you want. So this guy is a virtual pet that is completely working now, has the basic animations, has the pet, well, all this stuff is not, you see that it's dead just because the pet is actually dead. My save is too old and I haven't fed it. So we have our pet, which has a save file, which will appear in a few seconds. We'll have to wait. Well, okay, whatever, it will appear at some point. Why is this not happening? There you go. Oh my gosh, that took so long. There you go. So we have the last time fed. We had all the calculations for our 3 resources. We can feed it, we can sleep it, we can non-energize it, we can make it happen by playing a game. When we play the game, we have a mini game that is not perfect, but it's a prototype mini game made in 40 minutes. So it works. We have a flying pig that has to rescue the bunnies. We get the results and we get back to the basic screen. So that's a whole Tamagotchi made in a few hours. So yeah guys, thank you for watching, and I'll be right back with session 4.3, finalizing and fixing the minigame. So there's a few details that I will add, just 1 or 2 details, and then we'll finalize the whole tutorial series. So thank you for watching. Alright everyone, welcome back to how to create a virtual pet game with Unity. This is session 4.3, finalizing and fixing minigame. So our minigame has a few things that are not quite right, but that's not exactly what I'm going to fix. Like, oh no, of course not all of them. This is a tutorial about the virtual pet. We have to focus on the important stuff, and that is the virtual pet. So the thing that I forgot to do before with our minigame was whenever the minigame pet controller gets disabled, which, well, actually no, whenever the minigame, yeah, I mean whenever the minigame ends, be it won or lost, we have to update the pet to get some happiness. That's the whole point of the game, right? So we're gonna go to finish minigame, and either of these guys will do the same thing. So we're gonna go to the minigame pet controller, and I'm gonna say dot get component needs controller, and we're going to increase the happiness. That happiness, I'm going to increase it by 10. Basically, that's one thing that I want to fix really badly, because that's like, we're playing the mini game. I'm going to actually increase it by 20. We're playing the mini game to change happiness. Okay, that's better. So we're playing the mini game to gain some sort of reward. Well, so if we lose it, we'll gain 10, and if we win it, change happiness, we'll gain 20. So I'm gonna actually move this up here. So we have this correctly set up now, and that's that. That's nothing that I really want to test. So I'm gonna go into my minigame pad controller and see, why am I jumping so much? So why am I jumping so much? I'm gonna click on this guy. I'm gonna check my grounded. I'm gonna click play. Click this. We see that we are grounded now. If I hit space, I'm not grounded anymore, but I can still jump. So that's because I'm an idiot. And I'm gonna say, if not grounded, return. That's basically what I need to do. I hadn't checked. I was definitely checking correctly. I mean, setting the grounded correctly, but whenever I tried to jump, I was not really doing it right. So I'm gonna hit play again. I'm gonna go to my mini game, and I can only jump once, which is perfect. And I'm gonna set the jump speed to 500 and see what happens. That is way, as you can see, it's way too much. So I'm gonna hit play again, try another speed, but that's basically it. Those are the two fixes, the two outstanding fixes. What about if I do like 50? Oh, that's fine, I guess. I mean, we have to wait until this guy falls down, which will eat a lot of our time. So that's too much. Again, I'm gonna set it to be 25. And if you guys have that thing where it's too floaty, so you want to have the gravity scale be larger or your angular drag be larger, so I'm just gonna set this guy to be 1 and see what happens. We're gonna hit play again. Space. There we go. And here we can just wait until we fall down. Takes a little too long to fall down, I think. Well, I still can do it. So I achieve the goal, and when we come back, we have our pet all good. Okay, so that's basically it. That's all I wanted to fix is fixed. I don't want to make this tutorial longer than I should. So I'm just gonna move on to session 5. So I didn't do the sound stuff, but I will leave it in so that you guys can complete it. If you guys have watched most of my other tutorials, you will be able to see the sound stuff. So if you guys have any questions, just ask me about the sound stuff, but I don't think so, because all my tutorials have it, so it's no problem. So yeah, I'm gonna move on to session 5. This was session 4.3, guys. Thank you for watching. We are done. We have a functioning virtual pet. Goodbye. Alright everyone, let's go ahead and continue with how to create a virtual pet game in Unity. This is session 5, recap and further thoughts. So we're going to go step by step through everything that we did, the results, and whatever happens, right? So whatever happened, and some thoughts on how to improve this, how you guys can continue with this developing it into a more finished product or something that you maybe want to release, who knows. So the first thing that we're going to talk about is we installed the tools. That doesn't mean much. We checked some examples. I'm sorry, this one. We checked some examples of minigames. We checked Po, we checked Tamagotchi, we checked the UI, we checked the way that they did minigames. I am not too sure how to, there you go. So they made mini games. They have this UI that shows you stuff, shows you your food amount, your stuff, and it saves every time you leave. And then we scoped up project. After that, we set up the pet controller and some basic animations that are in our pet currently. So we have animator with a bunch of animations here that are not currently used, of course, but you can use them. I created them with Anima 2D and Anima 2D IK. Then we created the needs and the background, and actually I disabled the background. I never re-enabled it, but it doesn't matter. Then we have the needs, the time passing and fixes. We created some code for saving whenever you've last fed your pet, and the food amount and the happiness and the energy, all that kind of stuff. And then we continue to session 3. In session 3 we have the UI and the minigame wrapper. We created the UI, the beautiful user interface that we have here. We added some graphics, we added these lists, we hooked them up so that they work correctly. Then we added some buttons that also work correctly for feeding, for sleeping, for checking the minigame and stuff. And then we wrapped up by creating the base minigame controller, a very basic minigame controller. After that, after we finished with that, we went ahead and went into session 4. Session 4 was all about the minigame definition. So I'm actually gonna, no. So the minigame definition was just us defining how the minigames will work. We went into our whiteboard, and I'm gonna move this over here. We talked about having a minigame where the player can jump here and there, grab some objects, and then get the finished screen, which is very simple. And then we went ahead and implemented just that, all good. And then we finalized and fixed the minigame. That was all fine. So I'm gonna show you here. If I hit play, we have our data on our pet. It's already dying because the last time I fed it was way too long ago. We can also, of course, we have the settings here. We can go to the manager and set the length of the hour. So this hour length is a problem. It's like 15 seconds. So if I set it to be 500 seconds, then it's gonna be, of course, very different. And you can delete the save and restart so that you see the functionality again working just fine. Okay, so we have our background now. We can go and play the minigame. The background's a little weird, but it doesn't matter too much. So we can go ahead and grab these rabbits, and in the minigame we can just go ahead and, oh, it's a little hard because of the gravity stuff. Yeah, there we go. We got one, and we can move like this. I have 7 seconds. No. Come on, I can do it. 2 seconds, 1 second, and I did it. So I did it with 0.69 seconds left. We obtained 3 points. We see the background. We can go home, and the pet is back here. And that's basically the minigame. It works just fine. Looks very nicely. Looks very nice. I mean, and yeah, that's. I mean, what else is there to say? The game is complete. This is a very basic prototype. This is the way that you should do prototyping. Just go ahead and examine and scope your prototype, and of course judge what you need to do, and just go ahead and finalize it. Just do it. And so about further thoughts, what can you do to improve this game? So the thing that you can really do is add enemies. If you want, actually the real thing that you can do is add more mini games. The music doesn't really matter. It's just a little plus. But what you really do need to do is to have more mini games. So you have to design more mini games. Just go into a whiteboard, design some mini games. Maybe you have, you know, this maybe like a tree, and the tree spawns apples, and you have your pet moving around grabbing the apples, and you can die if you grab like a bomb or something. That's good. You can also add some effects. You can add some screen shake. Maybe when you grab the item, these things, you can add some screen shake, some music, some SFX. Of course, graphical improvements. My graphics are very, very basic because they're just free graphics from the asset source. Nothing really too special about my graphics on this virtual pet, but those are the things that you can do to improve. Also, if of course you at any point in 2 years, it's 2018, you watch this in 2019, 2020, you want to find me, just find Ramon Dev or find Natural Power Games, which is my company, and you can contact me, and I will help you with anything you need. No charge. I just, if you have some questions, I will not charge you to help you with some basic questions, and we can work together if you ever want to. So that is basically it for this tutorial series, guys. I hope you guys enjoyed it. I will upload the project files into the live.edu or the website, and you guys will be able to obtain this information for yourself. And yeah, that's it. I'm very glad we finished, and we have a very finalized product here. So thank you for watching. I will be back with more tutorials in the future. I hope you guys join me again. Thank you for watching.